Dwolla, Forte, Blockchain.com, Bitso, BRD, BitPay, Wire, BitGo. It's a really impressive list, very global, and I think we're really just getting started because at the core, PayID has tremendous potential to help enable these interoperabilities. During today's conference, you're going to hear from the engineers that help develop PayID. You're going to learn how to build with PayID and see demos from companies that are integrating it into their apps. I thought I'd take a minute before I turn it over to Ethan Beard and talk a little bit about why PayID. Why is this important to Ripple in some ways? Since the beginning of Ripple's formation as a company, now about 7-8 years ago, the vision has been to enable an internet of value. I'll talk about what that means in a second, but it's so, Warren did a good job introducing some of this, but how is it that we can literally stream video from the space station, yet I can't send my own money across different networks, across borders easily? I see PayID as a tremendous catalyst to enabling this internet of value, to help drive this interoperability. Our goal from the beginning has been to use blockchain technology to solve real problems with global payments. We started by building the payment network we now call RippleNet and using XRP to achieve instant settlement. The key on all of that has been interoperability, from network to network, from person to person. There are long-term benefits for society and companies when they lean into interoperability. We have seen that from the beginning of my career working in data network. As Warren said, sending a payment really should be as easy as sending an email, no matter where you are. I use this example of, no one asks when you're asking for someone's phone number, you don't ask, are you on Verizon or AT&T or Vodafone or fill in blank depending on where you are in the world. You just ask for the phone number. Why is it that when we're asking to send a payment, you ask what payment network you're on? Now, if we want to enable the internet of value, if we want to see massive success with something like PayID, much of this comes down to you, the developer community. You are the group that makes this reality possible. Spring, which is really Ripple's developer arm, is hoping to help with just that by providing the open source tools and code that any developer, not just the ones within crypto, can use to fix global payments. One of the reasons why Ripple is excited about this, and I'm excited about this, is we do have relationships with lots of the traditional financial system, and we can help drive PayID not just within the crypto system, but more broadly to fix the global payment network. The last, but certainly not least, before I hand it off to Ethan Beard, I wanted to share some exciting news, and if whoever's driving the slides, could click over. So as part of our efforts behind PayID, we are going to be donating $1 million to nonprofits focused on financial inclusion, racial injustice, and clean water. We have some incredible nonprofit partners as part of the Open Payments Coalition, including Give Directly, CARE, Mercy Corps, and the Water Project. They all see the value in PayID to make it easy for anyone to donate to their favorite causes, no matter where they are in the world, no matter how they want to pay. So we're incredibly excited to use this $1 million as partly us giving back and contributing, but also to catalyze some of the participation in PayID. More information on this is going to come later today. So with that, I will say it's great to be able to kick things off with you all today. I'm going to turn it over to Ethan Beard, who's been a tremendous leader here at Team Ripple and been a key champion in the vision behind PayID. So thanks again to everyone for being here. Look forward to partnering with you and making payments easy for everyone. Thanks very much.
Thanks, Brad. Welcome, everyone. I am Ethan Beard. I lead the Spring team at Ripple. I am incredibly excited to be here, incredibly grateful that you're spending time with us here today. So Brad, you heard him talk about the internet of value, enabling money to move like information moves today. And you'll hear repeatedly throughout today, how do we make sending a payment as easily as we send an email? And so let's just double click on that for 1 second. Like, why is it so easy to send an email? Well, if I wanted to send an email to any one of you right now, I wouldn't start by asking, do you use Comcast or are you on AT&T? It's kind of a crazy thought to even start that. I just get your email address and send you that message. And the important thing here is it is your email address. It's not your ISP or your email provider. But let me walk through a recent experience with a friend that I had that I think all of you will, it will resonate with all of you. And it went something like this. We had dinner the previous night, and I sent him a text. I said, hey, let me pay you for that dinner we split. was like, are you on PayPal? He's like, no. I'm like, Venmo? He's like, no. I'm like, Cash App? He's like, yeah, I think so. I was like, great, what's your cash tag? He's like, I don't remember, let me go check. And anyone who's ever tried to pay a friend knows this dance, is familiar with this dance that we all do as we try to find a payment network in common. PayPal was founded 20 years ago, and you still can't use it to send money to anyone that's not on PayPal. And as Brad alluded to, you can't even send it to someone on Venmo, even though Venmo is owned by PayPal. And the services that claim you can send money to anyone really mean send money to anyone so long as they're using our app. And that's why, if you think about it, all of these networks, payment networks, are actually quite small. P2P payments don't work with each other. Credit cards don't work for P2P. You can't really send money to my Visa card. And bank accounts operate in a whole different world. But what if it were like email? What if everyone used an open network? If every friend in every store could automatically accept it and no one had to check if you both had the same app or the same service? If it were that easy, I think we'd all be using digital payments many, many times a day. Quickly, easily, seamlessly. Payments today are fragmented across hundreds of siloed networks. And while it feels like the largest payment networks are really big, none of them come close to reaching all the people and all the businesses. And that fragmentation is friction, and friction is what keeps payments small. Thinking about it even more, the largest payment networks in the world today, they're built for machines, not humans. And so few of us have memorized our 16-digit credit card number. Receiving a wire transfer is so complicated that when you start a new job, we often give a paper check to our employer in order to receive our direct deposit payroll. And cryptocurrency tops them all up with 64-digit wallet addresses. That results in sometimes a lot of anxiety if you're trying to send a large value payment. While huge strides have been made in bringing payments online and accessible to everyone, payments are all still very complicated, and the number of steps it takes to onboard, send, and receive a payment is tremendous. This is Developer Conference. We're all builders here, and as builders, we know the cost of friction. Every screen, every step pushes your customers out of the funnel. Friction reduces volume, it drives churn, and it costs money. And the costs of the friction in payments is huge. We all collectively spend almost $2 trillion a year just to move around balances in databases. We think this can all be different. I can send an email to anyone on the planet, whether they're on Gmail, Outlook, or their own mail server. I can build a service, a business, that will enable others to send and receive emails to anyone else. I can have an email address that anyone can understand, such as at ripple.com or ethan@gmail.com. And the internet enabled this because it is an open network built on open standards and open source software. Imagine how big the web would be if we all had to memorize IP addresses for the websites we want to visit, like the New York Times. Or imagine how large Spotify would be if they had to negotiate with every ISP before they could offer their service to end users. And the web is so powerful that even Apple can't stop you from buying a Kindle book through their browser the way that they can stop you from doing it within the Kindle app. The payment network of the future will be open, allowing anyone to send money to any other person or business. It will be designed for humans with names that are easy to read and remember. It will not require a company's permission, signing a deal, or writing a check to build on. And it will be built on open standards and open source code. Like the web, you simply join by building your service on it. And like the web, the businesses built on this open network will be hugely successful. This is just the beginning. PayID is starting with the user experience because that's so important to get right. That's where it can remove the most friction. Providing human-readable addresses and a standard for sending money to them is very simple by design, but very powerful in its impact. Sending money as easily as email. Here's my address, just hit send. PayID is the beginning, and there are lots of other pieces to build in an open payments network. Domain names are an important part of the web, but it took HTML and browsers and servers and much, much more to make it work. And there was huge value created by the businesses that were early to the web, And there will be huge value created by the businesses that are early to open payments. And I really believe that now is the time. We are at a critical juncture for the future of payments. Companies like Apple, Google, WeChat each have over 1 billion users. Facebook itself owns 3 networks with more than 1 billion users each: Instagram, WhatsApp, and Facebook itself. And if these companies successfully add payments into their existing networks, users will be locked in a closed, fragmented, and friction-filled experience for a generation. And for every other company and developer, participating in these networks will require taking their terms and their tariffs. There's a short window to start an open payments network that works for all. Together, we can set the standards, we can build momentum, and keep the payment space open, competitive, and free. With an open payment network, a phone or a phone number will let you send, receive, and carry money securely. You won't have to pay a fee to send money or receive it, any more than if you were using cash. Paying a parking meter, a rent check, splitting the bill, making a donation, giving a tip, this will all be as easy as sending an email. For many people, this convenience will grow payments into something that you use every day. But importantly, for the 1 billion people around the world who have a phone but have no bank, the Open Payments Network won't just bring convenience, it will be life-changing. Their phone alone will make it easy to safely store money and exchange it for free. So, thank you for joining us on this journey. Thank you for sharing this vision of what the future can be. We are incredibly excited about PayID. We are incredibly excited to be working with such an amazing community. So thank you for being here. I'd like to now turn it over to David Schwartz, who is the CTO of Ripple, who's going to share some of the thinking behind the technology of PayID.
Thank you, Ethan. I've been working at Ripple for quite some time now. And for the last 6 years or so, we've been working on enterprise payments and bringing digital assets to them. And as we dug into payment networks, what we discovered is that they're very siloed and fragmented. There's a lack of standards. If you built connectors between payment networks, how would people use them? What would you hook them up to? It kind of felt like we were trying to build Twitter without the internet. You need protocols, you need infrastructure. And what I think we realized is that there's 2 big missing pieces that are not incredibly difficult to build. Like, it seems like an intractable problem where you have all these payment networks all around the world. There's money in all these different places and all these different forms. There's conversion. But when you look at what makes email so great, what you realize is 2 critical pieces are missing. So one of them is there's no standard for end-to-end messaging. If I'm going to make a payment to you, there is no standard for how my payment system and your payment system say, hey, I'm going to make a payment to you. And the other thing that's missing is simple universal identifiers. These are 2 very, very basic, simple things that messaging has had for a long time and payments don't have. And those are the big pieces that PayID brings. Next slide, please. Got the slides? Thank you. So we use the phrase the Internet of Value to represent the pieces that are missing, the things that we want to have in payments. These are connections between networks so that people can easily pay each other. It's not one giant payment network that takes over the whole world, just like the Internet behaves like one giant network, but it really isn't. It's a set of standards that connect different networks together to allow them to behave like one big network. We want to support large payments, but I think it's probably more important to support even very small payments, which requires very, very low cost. I think there's a lot of innovation that's limited by the fact that payments are expensive, and so being able to support very small payments, I think, is extremely important. And what we realized is that part of what makes email so great is that these systems interoperate technically, but also have that uniform naming convention with a single identifier. It's that standard for the communication part, and it's that single identifier that's missing from payments, and that is part of what makes email such a great experience. Next. So today, you have an identity that you use for payments, and it could be your name, your government-issued identifying number, it could be a phone number, and so on. But the pain point is that humans have to go through this negotiation. As both Brad and Ethan mentioned, do you have a PayPal? Do you take credit cards? Can I send you a check? Zelle might work. They might not even know it. And the payment systems don't really have payment setup negotiation. Many enterprise payment systems are fire and forget. The money just sort of flows without even checking to make sure that the recipient exists. This is not an internet type technology at all. In cryptocurrency, your account names are long and confusing. There's no directory of them, and they're tied to specific networks, which means if you change the sort of control, the company that you're using, or if you change your account, you wind up having to change your identity, and that risks sending money to the wrong place. And I think the last issue that we're concerned about is companies using data as a revenue source. So very often you'll pay somebody with an email address, but what's actually happening is the payment company is just going to try to onboard the recipient, which is a terrible experience for the recipient because they wind up onboarded at a large number of payment companies, or they wind up with payments that they can't accept. So companies are using identity to grow their walled gardens. That's not the way the internet should work, and that's not the way internet-based payments should work. Next. So our vision for PayID is that you would have a payment identity unique to you. It's not just technical interoperability, it's that identifier that keeps the complexity behind the scenes. So that if someone builds a way to connect payment networks together, they have a way for humans to access and use it without them having to find the right gateway. I don't know if any of you remember, but in the early days of email, there were email gateways between systems, but you had to say, oh, I'm on AOL and I'm emailing someone on CompuServe, so I need to use this gateway. Well, if you're going to build a gateway and then people have to go find it, that doesn't work. You want to keep the complexity behind the scenes. So payment setup negotiation, ensure the destination will accept the payment and has all the information they need. That's the critical part of the vision for PayID. Next. The PayID is a universal ID for payments. It maps human-readable names to wallets, just as an email address maps a human-readable name to a mailbox. And PayID is the protocol for that connection setup, and it supports regulatory compliance through that payment negotiation. If there's information the recipient needs about the sender, information the sender needs about the recipient, the PayID setup allows that information to be exchanged. And I think another important point is that it is a protocol layer. It doesn't take over the world. And this is important. If you look at protocols that have been remarkably successful, TCP/IP, which makes this conference possible, makes the web possible. TCP was built before the web existed, and TCP was built before probably all the technologies that we're using to move packets. If you're using Wi-Fi didn't exist when TCP was made. TCP enabled innovation both above it, like the web, and below it, like Wi-Fi. PayID also is a layer that doesn't put limitations on the layers above it or the layers below it. And this allows both innovation and interoperability, and it provides that human front end to complex payment discovery and path discovery. Next. PayID also is value agnostic. It can support both cryptocurrencies and traditional value exchange, hybrid services. It can support a person who may have multiple payment networks that they can receive funds on. It can provide a single solution to all of those sets of problems. The end-to-end communication solves those compliance and authorization problems, and its neutrality fully supports innovations in the ledgers that store value, the payment rails that transfer value, and the connectors that link them. Next. I do need to point out that PayID doesn't solve every payment problem. One thing that it does not do is it doesn't force payment systems to interoperate, even if they both support PayID. So an analogy might be if you adopt the internet, you can make data available, but it doesn't force you to make all your data available. You have to make a decision to make data available, and if people are nervous about these technologies, they're going to do that gradually, and as they build confidence, they'll take more and more advantage of what the technology lets them do. It would be very difficult for people to adopt PayID if they suddenly had to commit to exchanging value with everyone else who supported PayID. I mean, there are people, there are companies in North Korea that might adopt PayID, and companies in the United States, due to sanctions, can't exchange value. That's one difference between payments and email, and it does make the situation a little more complicated. But what it does do is provide a framework to provide that kind of support when people are willing to do it. The cost of admission is therefore low. You don't have to commit to running your entire business on it. But the benefits will depend on the level of commitment. The more people are willing to use PayID, the more benefit they'll get out of it. Next. So for crypto exchanges, PayID gives them travel rule compliance. It allows them to issue and use human readable names like email. They can manage deposit addresses conveniently. One of the annoying things is, for example, with Bitcoin, you may want to issue a different address to everybody who's paying you. That's quite annoying. An automated system that a person can use a single identifier and get a new address is incredibly convenient. And another big thing is PayID can support recurring and pull payments. Now, I know some exchanges have built their own systems to handle recurring and pull payments, but then that creates this problem that everybody has to integrate with all of these different systems. This gives a standard for that. For fiat payment systems, flexible payment discovery. So if you have a connector between two payment systems, it can find it painlessly. I can just give you my PayID, and if I'm on Venmo and you're on PayPal and there is a gateway between them, it can find it without me having to figure that out, because there is that that single identifier. My payment network can talk to your payment network and say, oh, you support these connectors. It allows them to issue human-readable names, so they can give out these identifiers that are can be accepted by other services and wallets. It allows them to interoperate with other non-crypto payment systems, but also interoperate with the crypto ecosystem if they wish to do so. And eventually, it will give them broad reach. Obviously, PayID will work only with other entities that support PayID, and hopefully that will be a growing group, and so it will extend their reach. For developers, they can work with existing web standards. We didn't create like standards from zero. We built on top of existing web standards and existing tools. They'll get flexible payment discovery, payment addresses that work like email, interoperability with both fiat and crypto systems, and hybrid services that work with both fiat and crypto. Next. So our design philosophy was to use conventional technologies that are easy for developers to use and deploy. We didn't reinvent the wheel. We didn't build. You can see that it fits in the web tech stack very, very nicely. We're very careful not to put in built-in biases. Implementation decisions were made as minimal as possible and motivated by technical merit. And I think this is similar to things like TCP, where if you look at TCP, it isn't built to favor Twitter. It isn't built to favor some particular, wired Ethernet, or isn't built for the web. It's built to make as few decisions as possible to enable interoperability, to allow people to do whatever they want with it. And you'll find that PayID has that neutrality. And because it's extensible, the cost of admission is low. There's sort of a minimum subset to make it useful, but then there's plenty of room for future extensions to offer more functionality. So it will grow with you. Next. So consumers can use a flexible payment system with support for pull payments and recurring payments, payment path discovery, so they don't have to do that sort of manual path discovery that we were talking about, where you try to figure out what payment networks you have in common. And I think pretty much all consumer payments. Generally, the way the technology is now, it works best with the customer on one end. The consumer can be on either end of the payment path, though. Consumer to anything or anything to consumer generally tends to work best. There's no difficulty supporting numerous small payments to different endpoints. This is a case that's very poorly handled by most systems today. And consumers will have more freedom to choose service providers that work for them, like with email. I think this is another interesting point. When you go to choose an internet service provider, you don't see an ad like, AT&T has all the websites you want, because every internet provider has the same reach. So you pick a service provider that has the features that make sense for you. This is not the case with payments. If you look at payment networks, Visa is everywhere you want to be. That's about reach, right? If you go to a store and they don't take Visa, what's wrong with them? They should take Visa. Everybody has Visa. So the difference is, when you have an interoperability standard that gives everybody the same reach, companies have to compete based on cost, based on services, based on the experience, based on matching the demands of their customers. And this is one of the things that PayID can do. Next. So today, customers have to onboard with many systems. They have to provide identity information to all of them. Many payments are fire and forget with manual status polling. The systems are old. The protocols are a mess. You might have a payment system that has a beautiful front end, a web app, brand new, all the latest technologies, but you don't have to go that deep beneath the surface before you're in the 70s with technologies that are based on, reel-to-reel systems. And so there's none of that live messaging. There's no status reporting. It's a mess. Next. So we can make things so much better. Onboard with one service, deliver value of any kind immediately and directly to the recipient. Compliance takes place behind the scenes. Discovery of paths take place with human effort. If people build new services and build connectors, they have a place to hook them up. And success can be known before the money moves, and confirmation can be provided. This is a tremendous improvement that we can make over existing payment networks. Next. So Michael Zakowski is going to come on next, and he's going to tell you how PayID actually works.
All right. Thanks everyone for coming here. I'm Michael. I am the lead of product at Spring, and I've been working on PayID for the past several months, and really excited to be showing off PayID here. Awesome to see how many people have come out to the event. So we've heard from a bunch of people about why PayID and what it is, but I think most of us here are devs, so let's get down to brass tacks and see how PayID actually works. So on the next slide here, a quick overview about our technical inspiration. It's been mentioned a couple times before that PayID works like emails for payments, and that also holds true at the implementation level. So just like in an email you can send to a simple human-readable address, user@domain.com, that will then resolve to an email server which heads some database, and ultimately you end up with a message in the right place. So PayID works very much the same way in both form and actual technical functions. So the format itself, user$domain.com, is immediately evocative of an email, which pretty much everyone in the world is familiar with. But it's at the same time very obviously tied to payments, and also has, by being distinct from email, some security and privacy features that we'll be discussing later in the technical deep dives. Now, when you actually get a PayID of this form, what ends up happening is that resolves into a way to hit the PayID server, that hits a database, and then you're simply returning a response with the right account numbers. So on the next slide here, what does this actually get us? Well, this is built pretty much just on your standard web tech stack. There's nothing really special going on underneath the hood here. That actually has some really powerful properties. Most importantly, we get a single ID that provides a uniform interface for all payment rails. So what does that mean? It's a uniform interface that works across all wallets, all places where you would be storing your money, in a way that makes them interoperate very nicely. So that's one. And then two, you have a single PayID that can work for all of your payments. You no longer have a hodgepodge and medley of different addresses that you have to keep track of, and often in a form that's completely inscrutable to anyone who wants to send a payment here. So what we're trying to highlight here on this slide is that PayID doesn't only work for crypto payments. We'll be seeing a bunch of crypto payments here, but we'll also be hearing from some partners in the traditional rail space. So you could very conceivably have a single PayID, user$domain.com, that works for crypto like Bitcoin or XRP, but also traditional rails like ACH and Visa in a pull context. And on those latter two, we'll be able to enable those interactions in a secure, private, and safe way. And if you're interested in learning more there, please stay tuned. We'll have a demo and also a technical deep dive on how we can enable PayID over technical rails. So what does this actually look like underneath the hood? On the next slide here, it shows some technical details here. So we start with a PayID. It's simple, human readable, user$wallet.com. That resolves to a deterministic HTTP endpoint. Now there's some proposals out that we have to allow arbitrary paths, what we're calling PayID discovery here, but in the most simple basic default configuration, it would point to something like wallet.com/user, substituting, of course, in the right domain and the username there. Now, once you actually have that HTTP endpoint, now you can query it. We're establishing basically a secure channel between the two transacting parties, their wallets, in a way that all of the complex details of resolving a payment can be fully abstracted from the end user. So on the right here, we see two different examples here of what messages actually get passed. The sending wallet will say, hey, I want to send XRP, or I want to send Bitcoin to this particular PayID. Those details are encoded in the header. We also have a version number in there, but we see a simplified version here also of the response. So we were just returning a simple JSON object that has all the details that you need, the address, the metadata, things like memos that can complete the transaction. So again, I want to emphasize here that this is a very simple setup here. We're not doing anything super complex or totally groundbreaking here, and that's very much intentional. We wanted something that's easy to deploy, easy to use, simple to manage, and accessible to all. So on the next slide here, we see what this actually can be extended to. So we start with a very simple set of bits, a secure communication channel between wallets, in a way to find that in a human readable and user-friendly way. And then you can expand that in a really large number of interesting ways. So we've thought of several of these. I'm sure there are many, many more that are possible here. But some of the examples here that we'll be touching on today are things like checkout, using PayID in more complex ways than just a push payment. Things like polls, subscriptions, recurring payments, verifiable PayID, which are some security enhancements that I touched on. Compliance and travel rule, a very important issue facing the space today in crypto, and obviously is really fundamental to payments generally. Ties into digital identity, forwarding and aliasing, your standard web stack things, and then roll out a more complex protocols, things like Interledger, another thing that we work on. So that's an overview of how PayID works technically. How, if you're a developer, what does this actually mean to you? What does this look like to integrate into your application? So on the next couple slides here, we break this down into two different problems, really. There's first the receive. How do you give users on your application PayIDs, the ability to receive funds within your service or application to a PayID? So long story short, PayID really breaks down. When we say PayID, there are kind of two things that we talk about. One is the open source standard, the set of rules that PayID follows. And then there's also implementation. We've rolled out a reference implementation server. It's built solely on the tech stack. It's really simple, easy to deploy. I've deployed it several times myself. I am very much not infra developer, so it certainly points to how simple and easy it is. And then once you, at least in our reference implementation, there is a private API that's really simple CRUD style user management that would integrate very seamlessly into an existing account system or on a standalone basis. And of course, this is only a reference implementation. Anyone is welcome to download it. It's available on GitHub under the PayID organization and maintained by the Open Payments Coalition. But anyone, of course, is welcome to build their own implementation against the PayID standard. So please, if you're interested, check out both the reference implementation and the standard, both available in the GitHub repositories. Go to payid.org to get a link to there. So that's one side of the equation. The second side here is send. So what if you actually want to enable your users in your application to send to a PayID? So this is even simpler than the receive part. There is a standardized HTTP API. It's super easy to query either through curls or just standard API queries. We also have on Spring Team a Spring SDK that exposes all the things that we work on, among them PayID, and it's a super simple client, lightweight, easy to get into your application, and does all the work for you in just a few lines. So a variety of options out there for you, and for more will be developed in the near future. Great. So hopefully that was illuminating overview of how PayID works. We have a number of technical deep dives again later on in the agenda here. So if you're interested in learning more, please check out the docs or stick around for those presentations where you'll learn a lot more detail if you're interested in integrating these into your apps. So let's move past this here and into the interesting part where we actually see demos. So first we're going to kick things off with the charity application that Brad announced earlier. So we're super excited about this. We're committing $1 million overall across a number of different initiatives. This is the first component of that initiative. So on the next slide here, we see here, if you're interested in checking out today, please go to payid.org/give. I'm going to show you guys right now here an example, a walkthrough of how this actually works. And our goal here, really, I think we can all admit that it's a pretty crazy time to be rolling out some technology. And so we wanted to couple this rollout, launch of PayID, as well as this conference, with a way to also do some good while learning more about PayID. And so we're really excited here to have this application where you or anyone can log in, get some funds from courtesy of Ripple, and donate to a number of really high impact charities. So let me share my screen here, and we will dive into how we go about and do it. So on the slide there, you can see payid.org/give, super simple URL if you just go there at any time in the next couple weeks. then you'll be able to access this. So this is the main PayID website. There'll be a simple survey here, fill out some information so we can keep you in touch with everything and all things PayID. But ultimately, this will bring you over to the Spring site login here, which is the team I work on. And so it's a simple sign-in with GitHub. We are certainly looking to engage with developers here, and we go into the charity payout app. Now, I've already initialized here. There'll be a brief description of how this actually works and why PayID can make life easier for not only applications but also organizations like charities. So I've already given a few XRP here, but you're loaded up. Anyone who logs in right now will be loaded up with 100 XRP. This is on the testnet. The funds will be sent over in batches going forward to the various charities that we support on the site. But right now we support 4 charities. We're going to be hearing from each of these just after this here. So we'll get a little more detail on what exactly the different causes that you can come in right now and support using the funds that Ripple gives you to donate. And as you can see down here, we're tracking the history. I've sent to CARE, Water Project, and Mercy Corps. They're very simple here. We can see the different PayIDs of the various charities that are available, and we can simply click Donate with PayID. This is going to pull up the PayID of the particular charity that we want to donate to, and I will donate to Give Directly, great charity, 10 XRP, and I'm going to click Confirm here. And it's going to be processing. The implementation here is doing a full send and confirmation, which on the XRP ledger happens within about 4 seconds. So this transaction is fully gone through. And we can see on the Explorer here, if I just refresh, that in fact there has been a 10 XRP transaction. So it's as simple as that. And this is really meant to demonstrate how this would work in an actual application. We'll see in a second some real world implementations of this. But please, everyone, feel free to go today to payid.org/give to donate funds to these charities today. Great, so that's a quick demo there. Before we move on to some of the other partner demos, I wanted to give an opportunity for the various charities that we are participating in PayID, and we're happy to support through this application today. So we'll first turn it over to Joe at Give Directly. And Give Directly is working to enable donors to send money directly to people living in poverty. So take it away, Joe. Joe, I think you might still be muted. I don't think I can hear Joe right now. Hopefully it's not a problem on my side. Why don't we come back to you, Joe, if that's all right, towards the end, and we'll go straight then to Alejandra with CARE, who is one of the largest charities in the world fighting poverty globally.
Hi, can you hear me?
Yes.
Hi, so I'm Alejandra Villalobos, the Executive Director for the Western Region for CARE. CARE is a leading humanitarian I apologize, there's a problem with my sound.
I can hear you just fine, Alejandra.
Great, okay, so CARE is a leading humanitarian organization fighting global poverty with a focus on empowering and meeting the needy women and girls. Last year, CARE worked in 100 countries and reached more than 70 million people, doing everything from domestic violence counseling in Rwanda to granting business loans to Syrian refugee women, providing critical sexual health services to women fleeing Venezuela. CARE has been supporting financial inclusion globally for over 30 years, first as a leader in the early microfinance and impact investment sectors, and more recently through our Savings Group initiative, which is on track to increase access to finance for over 60 million people worldwide, including 50 million women and girls by 2030. Since March, CARE has responded to the COVID crisis in 67 countries. We've reached close to 10 million people directly in the last few months with life-saving hygiene kits, food, cash, and information about preventing the spread of the virus. We're excited to have the opportunity to participate in PayID, to use it to receive charitable donations in any payment form, including crypto. Thank you again for this opportunity.
All right, thanks so much. So next up, we will hear from Alpin at Mercy Corps, who helps communities achieve prosperity in the face of disaster and helps alleviate poverty. Over to you, Alpin. We have Alpin here. Might have been a bit of a tech difficulty. All right, so why don't we move on here? We will now turn it over here to Peter at the Water Project, who provides access to clean water across sub-Saharan Africa. Over to you, Peter.
Hi, everybody. Can you hear me okay?
Yes.
Great. So yeah, I'm Peter Chassie, founder and president of the Water Project, and I just want to start by saying we are really excited to be here and to say thank you. This community is amazing. The crypto crowd, really, I think of you all as a community, has been incredibly generous to the Water Project over the years. Gifts of Bitcoin and Ethereum and XRP to the Water Project. They've quite literally made our work possible. We were early into the crypto space, and from the very beginning, we just saw this outpouring of generosity and this move towards charity. It wasn't normal. And so we noticed it and we got involved, and you guys have been incredible. It's been amazing and transformative to our work, and I really can't overstate that. We build water and sanitation systems in Kenya, Uganda, and Sierra Leone. These are folks that just do not have access to water, spend hours every day walking back and forth to dirty sources that are making them sick. And so through our local teams, the Water Project provides that safe and reliable water in over 1,600 communities. And that's today. You can see every one of those water points and their status, whether they're working, need a little help, or actually are down. You can see that in real time right on our website and our app. We prove that water's flowing and is reliable. We tie every single gift directly to impact that you can track and the communities can track. And now more than ever, because of that, we've become a reliable partner in each of these communities where we do provide water. When COVID hit, the Water Project teams on the ground were able to leverage the trust that we built to share critical information about how to fight back the disease in these remote areas. We serve an area in Western Kenya, for instance, that's about the size of northern New Jersey. We visited nearly 800 communities there just since April. We've been teaching mask making, hand washing, social distancing. And with your support, it's going to be hugely beneficial in preparing these communities for when COVID does arrive. And we're seeing the numbers grow every day in Kenya. We hope it stays out of the rural countryside, but we can't guarantee it. The communities are so thankful. Our website is filled with videos and pictures of people learning how to make masks and to understand that soap and water is their weapon against this disease. Brings more peace than you can imagine. So we're really excited to be a part of the PayID initiative, what that's going to mean for charity giving. But we also see a vision for what PayID can do in our day-to-day work. We have been hopeful for the ability to move crypto all the way through the chain into the field. We think PayID may play a critical role in that, and we're excited for that. Finally, I just want to encourage you all to sign up at the link up there. Take advantage of this generous gift from Ripple. These gifts are real. It's real money that's going to have real impact in real people's lives. So please help us keep water flowing, and thank you.
All right, thanks so much, Peter. Next up, we will have Alex from Giving Block, which is an organization that makes it easy for donors to give crypto to a variety of charities. Over to you, Alex.
Thanks, Michael. So I'm Alex. I'm one of the co-founders of the Giving Block. Like Michael said, our entire mission is making it as easy as possible for nonprofits to be able to accept a variety of cryptocurrencies. Obviously, when we heard about PayID, it seemed like a perfect fit for our mission because anything that makes it easier for the average person to use, whether it's sending or receiving cryptocurrencies, is a huge help. So we're excited to be bringing PayID to our clients. You just heard from Peter from the Water Project, which is one of our clients, and they were actually our first implementation of PayID. So that's already live now, and I'm actually going to share my screen and walk you through how easy it is to use. Michael, is that coming through?
Yep.
Awesome. So this is the Water Project's donation page here. And if you scroll down here, they have an option for their other ways to give. And then you're going to get this pop-up, which has our cryptocurrency donation widget over here on the right. Down here, you'll see the option that we added for PayID. So if you click PayID, then it's going to give you an optional form to leave your information if you'd like. If not, you can click this box and continue anonymously. Then on the next page, it's going to ask you how much you want to donate or pledge. In this case, let's say $100 for the sake of the example. Then you're going to click pledge. It's going to confirm that you want to donate $100 worth to the Water Project. And then on this last page, it's going to give you the PayID that belongs to the Water Project. So this address is already live. So you could go on to Bread or BitPay or any of the other wallets that have PayID already integrated and send a payment directly to the Water Project for any of the supported cryptocurrencies. And those payments will go directly to the Water Project. So feel free to, in addition to making those testnet donations, go ahead and try it out with, Bitcoin or your favorite cryptocurrency and give it a shot today. So appreciate it. We're looking forward to getting other nonprofits onboarded with PayID and think it's going to be a game changer for making it easy for nonprofits to accept crypto.
Awesome. Thanks so much, Alex. So we'll circle back here to the top of the batting order. Certainly, it's not a video conference without some technical difficulties, so we'll turn it back over to Joe, give it directly. Still having some challenges here. Can't hear you now. All right, well, we'll put in a pin in this. Let's circle back here after our next two demos because it actually will transition very nicely back into Give Directly here. And we'll also check back in with Mercy Core after these next set of demos here. But overall, please go, if you're interested, to payid.org/give and give the chance to give other people's money to some of these great causes. So let's now move on to the partner demos here. And these are going to highlight in a few different ways how PayID can improve user experience across common payment use cases and also beyond. So first, we're going to start with something that hopefully is very familiar to the entire audience, a peer-to-peer payment. And for that, we're going to have one of the leading non-custodial wallets, BRD, one of our close partners. And Adam there is going to show how PayID is now a part of BRD. Over to you, Adam.
Great. Thank you very much. Greetings, everyone. I'm going to go ahead and share my screen here. Bring up a couple slides. All right. All right. So my name is Adam Trademan. I'm the CEO of BRD, and we're excited here to be a part of the PayID Developer Conference today. Since the beginning of BRD, we've always been focused on simplicity and having a great user experience for our users, whether it's in our consumer wallet app or in our enterprise product Blockset. When we started the company, we really focused on mainstream adoption of cryptocurrency and digital assets. Part of our vision was to be able to make crypto as easy as sending or receiving an email. And so with the launch of PayID, we can finally realize that portion of our vision. And today you're going to be seeing a demo of the consumer app with PayID support. But just to talk briefly about what it was like to perform the PayID integration. So fast, better and easier than expected. It took us about 3 weeks in terms of calendar time, one developer across both the iOS and our Android platforms. The PayID dev team at Ripple was very receptive to our feedback, quick bug fixes, wanting to make improvements, and the features and function of how it works just really integrates well with our focus on UX and simplicity, anything that makes it easier for consumers and mainstream adoption of crypto. The user feedback since we released PayID in both of our apps on both app stores has been positive, and we're excited to be here today in order to show you a quick demo. So I'm joined by Adam Zadikoff, who's BRD's COO, and he is going to show you a demo of the BRD consumer app here shortly. Thanks, Adam.
Yeah, thanks. I'm also excited to be here. Thanks for having us on. I'm going to share a quick demo of how this works within the BRD app. Looks like Adam and I showed up in uniform today. That's good to see. And all right, so I'm going to just share my screen here. All right, can everyone see that? We've got an iPhone with the BRD app loaded, so I'm just going to open up my app here. And beauty of PayID is how simple and quick it is to use. So you'll have to follow along here as I move quickly through this. I'm just going to send some Ethereum. I've already saved the PayID I want to use. Within the BRD app here, the nice thing is that we detect the PayID. We ensure that it is a valid ID with a valid address behind it. So behind the scenes, we do a really quick check to make sure that you actually have a valid address that you're sending to with that PayID, and then just send $5 worth of Ethereum over to Sergio. Click send, make sure it all looks right, and off you go. That's pretty much it. It's as simple as that. And the nice thing about the PayID is you can put that into as many different currencies as you want. If that PayID accepts various currencies, you can use the same one across Ethereum, XRP, Bitcoin, all of those. That's it. I'll hand it back to Michael.
All right, thanks so much. It's really exciting to see after the entire coalition for several months on this launch here. So it's great to see it in the real world, live in a really phenomenal wallet that's focused on making the user experience as easy as possible. So awesome to see the interoperability benefits and the human readability aspects. So now we noticed that if you're paying close attention there, the PayID that was sent to in that example was to Sergio, who is at the Tangum wallet. So now Sergio is going to be showing us here in just a second how they are thinking about integrating PayID and have actually integrated PayID. So we'll see the transaction that was just sent out in the previous demo in just a minute here, but I just want to touch on one of the key philosophies behind PayID, which is security. We operate in a world where real value is moving. And we want to make sure that we are protecting users to the greatest extent possible. So PayID is really built around security. There's a deep dive later that I welcome anyone who's here to please attend. It'll be on the same presentation that dives into how we are addressing security at a technical level. But first here, we will see from Sergio here, who is with Tangum, which is a hardware wallet that's focused on both security as well as user experience. So I'll turn it over here to Sergio, who'll show how PayID is a perfect match for that type of environment. Sergio, are you online here? All right, looks like the presentation, the video conferencing gods are not favoring us here today, but we'll try to circle back to Sergio in just a second here. And we can complete this demo and then also hear from the final two charities. But before we go there, we'll give Sergio a chance to debug any technical difficulties that are happening on his side. Let's move on here. We've been operating here in the world of peer-to-peer payments, where you have improved user experience, the ability to send the multiple currencies to the same PayID, where the transactions are completed on a number of rails. But so far, we've only seen push payments. And that's great in a peer-to-peer context. But the reality is that things like e-commerce and other transaction types that are common in all of our lives typically happen in a pull fashion. And there are other more sophisticated transaction types like subscription payments. So if Sean is on here, we're going to move on to the next demo here with BitPay. And this will be more of a high-level presentation. But what BitPay is going to be showing us here, and that's in a few slides here, you go, is how we can actually use PayID to enable these new types of transactions, at least new types in the crypto world. So I'll turn it over to Sean. Awesome to have BitPay here. Obviously, great to learn and see how the leading companies in the industry are actually thinking about implementation. So over to you, Sean.
Thank you, Michael. Appreciate that. Some good demos. So yeah, my name's Sean. I am the Director of Product Management Design at BitPay. We're the world's largest global payment processor for cryptocurrency, process on average about $1 billion worth of crypto payments per year, a bit over 1 million individual unique payments. We process payments for other great, nonprofits too. Greenpeace, we work with CARE, of course, AT&T. So been around since about 2011. So we've definitely had a lot of experience with crypto payments. So I'm just going to talk a little bit about some unique challenges when building for payments with crypto. Kind of talk about how PayID is aiming to address some of those, and then give you probably like a little 10-slide demo of just what we're thinking of how this would work. There's a lot of different use cases for payments. So I'll show you something that we've kind of been thinking about. So the first thing that's unique, with payments and building on the crypto space is you have to account for security, of course, first and foremost. If I'm building just a regular challenger bank app, or if I'm building just regular, hey, accept credit cards for businesses, there's a lot of inherent security already built into what I'm doing. If a user loses funds or doesn't get access to their bank account, it's more of like an account access issue versus your funds are gone forever. So that concept, as you're all very familiar with, is very important, not only for the user who's holding that crypto, but also for businesses who are accepting that payment. And then another unique thing with crypto around payments is how closely we have to build to the actual protocols, the Bitcoin protocol, the XRP, ETH, the ERC20 type of stuff. I mean, we're right next to the actual protocol layer when making these payments happen and allowing businesses and users to interact with them, really only semi-abstracted even a layer. And then in some cases, as like when a user is sending funds to an address, a crypto address, directly interacting with that protocol. I mean, that's unique and really real, and honestly pretty scary for businesses and mainstream users when looking to make consistent, real world, all the time payments using blockchain payments and crypto. So that's kind of some challenges we deal with, as well as education. Of not only the businesses but also the consumers. So for businesses, how do I receive crypto? How do I set up a wallet? For consumers, again, how do I pay to this weird address? What if I mistype that address? Are my funds gone forever? When using credit cards, it's and other forms of payment, bank transfers, much lower level of education required than crypto. So that's what I'm really excited about, and BitPay is really excited about around PayID. Is this allows the users to operate with payments specifically and sending and receiving across all forms, not even just crypto. Allows them to do that without having to be so worried and such a huge level of education that they need. Again, kind of referencing like, what is this address? Wait, I want to pay with Venmo. Wait, I want to pay with PayPal. Wait, I want to pay with ERC20. That's all different types of learning. So we love that PayID is kind of focusing on bringing all of those together And the easier that it is for consumers to pay from whenever capacity they want to, from wherever they want, with whatever they want, the easier it is for businesses to accept payments, to make money, to ease commerce. Reducing that friction for payments is such an underrated kind of concept and really drives a lot of growth globally. When payments across the world, the friction is dramatically reduced. So we really love where PayID is heading with that. So I'm going to show a quick demo here about just, this isn't in production, but this is just something that we've really been thinking with PayID around payments. I'm going to go ahead and share my screen. Okay, I think I'm sharing now. Okay. So this is a standard BitPay, what's called an invoice. Or this is, once a user is on, you'll see Newegg here. That's a global electronics provider. You can buy computers, things like that from them. But when you click Pay with BitPay or I want to buy with crypto, this is the first screen that pops up. And you'll see we ask, hey, where are you trying to pay from? Again, there's so many different options where a user can pay from with so many different issues on how a payment can happen. You'll see PayID here. When a user's like, oh, I have a PayID, I'll click that. So next we'll go, well, enter your PayID. Let us know who you are or like where you're trying to pay from. A user enters their PayID, and maybe that PayID is specifically in this demo related or attached to their BitPay app. So this is kind of inverse, where a user tells us or the business, hey, here's my PayID. That means here's where I want to pay from. And next we'll show, okay, we're going to connect to your PayID here, and we're going to authorize that. And then, so now this is going to switch. That last screen was about a user paying on their desktop, which is about 80% of all payments start on the desktop when paying. But now this is switching to a mobile flow where a majority of crypto is held on mobile devices. So this is mobile. It's like, okay, wow, I just got this payment request into my BitPay app. I want to pay Newegg. And BitPay app knows this is you because on the background with the PayID servers, it's registered with this BitPay app. Okay, cool. I'm going to open it up. I've got Bitcoin, I've got Bitcoin Cash, I've got Ethereum wallets. Which one do I want to pay with? I'll select Bitcoin. Here's kind of the details of the payment that you want to do. It's going to Newegg. You're paying with Bitcoin, the exchange rate. This is how long the exchange rate is guaranteed and the total amount of Bitcoin. It's already pre-filled with me through that back-end communication. Again, like it's lowering that level of education needed, lowering the error chances, the chances for error. Okay, I'm gonna slide to pay this. I agree with all the transaction details. Great, payment sent. Now I'm looking at my desktop here. Success. It automatically communicates again on the background utilizing BitPay payments as well as PayID. And now you've just successfully utilized your PayID, pay with any cryptocurrency. You didn't have to enter an address. You didn't have to be worried about making a mistake with too low of a fee where it never confirms. The business is confident they're going to get that money on time, every time, and they can release the goods and services. So again, that's kind of how we're looking at it going forward, and really excited to see where this is going to go and taking part with PayID. That is all I have there.
Awesome. Thanks so much, Sean. So just want to touch on again here. I love that flow. That demo is awesome. There are a few things that stand out to me there as I think about what the user experience that we want to push is. And so the first is we are minimizing the amount of info that a user needs to know in that flow. So at least my experience, whenever I type in my email, I can type it in super quickly because I type it in for every login. I know it's familiar, it's related to my name, so it's pretty easy to type, much faster than when I have to type a new email that I haven't seen or copy and paste it. So in the peer-to-peer flow, you certainly get a massive improvement over the current status quo of sending to a complicated address. And in this flow, you get even another improvement, another level of improvement, where you only really need to know one thing as a user, your own address. And that's super simple to know. Second here, we're telling the users what they can pay with rather than having them either requiring them to know up front or making them guess. So you put your PayID in, you're automatically resolving what the shared rails are, and you're saying here are the options, and you get to very easily select one without having to know that in advance. And then finally here, just with all these demos, we're just emphasizing the protocol abstraction that comes here. The user doesn't really have to understand anything at all about how to pay in that demo. All they need to know is, here's my PayID, and I can figure out, it tells me, holds my hand the rest of the way down. So really awesome to see that. Now we're going to move on to a related demo here that we at Spring have actually been working on. So we've seen here with Sean's awesome demo how checkout can work. So let's see this actually live in practice here. And we're actually going to show a slightly more complex payment even than what we just showed there, which is a subscription payment. And I'm really actually personally excited about this because subscription payments are really tricky to do in crypto today. So Neil with the Spring team is going to show us how that can be achieved using PayID in any wallet. So over to you, Neil.
Yeah, thanks, Michael. So I'm Neil Hartner. I'm a developer at Spring. And I'm going to give you a demo of what we're calling PayID Commerce. And as Sean and Michael have highlighted, we want to give a sort of seamless checkout type experience, something similar to like a PayPal checkout that people are familiar with, but using PayID, where the user simply has to put in their PayID, and between the merchant system and the wallet of the PayID, they can negotiate what the payment is supposed to be, and maybe even more additional details like shipping address. That might be in the future. And I'm going to show subscriptions because this shows kind of a interesting and tricky thing to do with crypto, which is even if you're not doing a subscription, a lot of times when you buy goods online from, say, Amazon, they typically don't charge you. They might authorize your credit card, but they don't charge you for the funds until they ship the goods. Whereas with crypto payments, you're typically paying up front, and if the merchant later on discovers, oh, I'm back ordered, I can't fulfill it, then they have to do a refund, which can be kind of tricky with crypto, especially if the address you paid from is not where you want to get the refund sent back to. So it'd be really nice if merchants could wait until they're ready to charge you in order to pull the money from your account. And a subscription is just one form of that, where I could have a subscription for Netflix, and although I may sign up for Netflix today, they may not charge me for that subscription until a month later. So I'm going to share my screen here. Let's see. You should be seeing a screen with my phone and a browser. Is that, Michael, can you see that? Okay.
I can.
Perfect. Okay, so we created a site. This is just a toy site, but it is live. It is public. You can go visit it. It's chefxrp.shop. You can imagine it being, the premier site of cross-border food delivery, being XRP. There are some instructions, or at the moment, it only works with the Sum app, and I'll get into that. So what I'm going to do is show that when I come to the site, they're going to ask me what my PayID is. I'm going to put in Hartner Spring Money. So I had created a wallet on Spring IO. Anybody can go create a wallet there. It's testnet, so this isn't real funds. And then what I've done, so I'm going to log in with my PayID. Using that PayID, Chef XRP site is able to look it up and figure out that I do have a wallet that supports XRP. I've also, using the Sum app, which is an awesome new mobile application for managing an XRP wallet, I have imported my Spring Money account into Sum so that Sum can do things like sign transactions for me, and also show that it's going to do push notifications if I'm not present when the merchant wants to charge me. So Chef XRP has some different subscription options, breakfast, lunch, or dinner. I'm going to go for the dinner, and I'm going to subscribe to it. And to make the demo interesting, it's going to be a 10-second subscription. So every 10 seconds, Chef XRP is going to request that I pay, 18 XRP in order for them to fulfill, this hypothetical dinner delivery. And when I click complete purchase, what's going to happen is that through PayID, they're going to go look up for my PayID what is my wallet, redirect me to my wallet so that I can approve this subscription. And then once I approve the subscription, they'll get a notification back from my wallet saying that I've approved it, and then they'll start scheduling these subscription payments to be done. And then I'll be getting payments from Chef XRP to my Sum app asking me to actually pay them. So let me complete purchase. And you can see it's figured out that I need to go to Sum, and I've got a notification here on my phone I'm going to click into for Sum. And it's asking me to approve this dinner subscription. I'm going to accept. And now it's going to redirect. It's been notified the merchant that the subscription is complete. I'm even going to close the tab, close some. So what should happen here in is about 10 seconds. The merchant backend system for Chef XRP is going to request payment from my Sum wallet, and then I'm going to be able to open that up and approve it. Waiting. Let's see, maybe that's. Like I've hit a demo snag. Let me try it one more time. I'll subscribe to lunch. I think I might have chosen a 10-minute thing. I'm guessing that's what I did wrong. Let me try it again. Again, I'll get a push notification to sign. Accept. Out. Back. See, hopefully this time I start getting, there we go, sign request. So now the back end has sent a request to my phone to request payment. And I can see that. It's an invoice from Chef, if you see over here, and I'm getting a ton of them now because they're coming every 10 seconds. So I'm getting an invoice from chefxrp.shop. Pay them, so I'm going to go ahead and accept that for 18 XRP. And close, and I'm getting spam now, so what I'm going to go do is go back to Chef XRP, and I'm going to cancel my subscription. And this will then stop these subscription payments from being requested from my wallet. And I can even go into my Spring Money wallet. If I hit refresh, I can see that I sent a couple payments to chefxrp.shop for 18 XRP. So that's shown the end-to-end, the ability for the merchant to pull a payment from me. And this was done through a non-custodial wallet where obviously, like, I as the customer have control whether I want to pay that or not. This would work even better in a custodial flow. You know, if I'm asleep, my custodial wallet on my behalf could approve that payment for me. And so we think that PayID Commerce will be a nice way to give that PayPal, you know, e-commerce checkout experience to customers. And we'll be doing a deep dive later on to go into more details about how this works and answer some questions on that. So hand it back to Michael now. Thank you.
All right, thanks so much, Neil. Neil is well on his way to feeding his family here with multiple subscriptions, but that was an awesome demo. Just want to touch on a few things there. We're able to start with some really simple bits here with PayID. You use a human readable name to establish a internet connection effectively between the sender and receiving wallets, and you get some really powerful experiences out of that. You wouldn't be able to have that notification system, that recurring payment paradigm without that connection. And in the context of crypto, that's really a net new thing. You can't do that if you're just starting with a blockchain address. And outside of crypto, there's some really exciting applications too. Having a uniform interface, as well as potentially empowering users here to manage their own subscriptions and have better control over their funds. So a few things to follow up there. First, quick shout out here to the Sum app, doing really amazing work with thinking through custodial, or rather custody of keys and approvals of transfers. BitBns has done a ton of great work on that. If you are interested in checking out the Chef XRP demo, there is a blog post right now on spring.io. If you just go there and go to the blog, that gives you all instructions of how to replicate it yourself. Like we said, this is something that really proof of concept works with the Sum app, but potentially in the near future could work with any wallet that chooses to integrate into this PayID open standard here. And if you are interested in learning more, please stick around for the technical deep dive later. All right, so let's rewind in time here just a bit. Let's go back. Last time we checked in the peer-to-peer space, we left the BRD team who had just sent a transaction to Sergio. So just to refresh everyone's memory, PayID is really designed with security in mind. in addition to user experience, and the team over at Tangum has a similar philosophy: great user experience while providing strong security through a hardware wallet. So we'll turn it over here to Sergio, who hopefully, I know ETH isn't the fastest network out there, but hopefully by this point he'll have received his Ethereum that Adam had sent him. So over to you, Sergio.
Hi, Michael. Thanks for handing off. I'm great, and I'm happy to announce that although ETH is not the fastest network of them all, we can instantly check on my Tangem card, and we see that we have quite some balance there, 0.049. If we go in the Explorer, we'll see that the latest transaction came 23 minutes ago, and it was 0.021 ETH. So yes, it works perfectly, and as you can tell, on the Tangem app, we've just developed the PayID functionality. So when we tap a card on the screen, you can then check how to load this card, and my PayID identifier is just there at the bottom, sergio.eth@payid.tangem.com. How do we get here? Well, Tangem has always been very proud of its interoperability framework. So I did also prepare a couple of slides on this, on slide 38. It's we come from a background of secure chips and embedded chips. So the one chip you see in this Tangem card comes from 10 years of development, and specifically what we manage is to grasp the most complicated parts of secure chips handling and the most complicated parts of cryptography, and have them coexist together in a secure element. So we use a secure element as a processor to compute cryptography, and specifically for compiling signatures for SECP256A1, Edwards, RSA, basically anything that the modern systems require, obviously including blockchains. So we've always been very proud of our interoperability, and the demonstration is that we have this beautiful set of cards for every single cryptocurrency in the market. This is possible because, as is shown in the slide, we have a very clear distinction of the layers that make this possible. At the bottom end, we use secure element chips. Currently, we're using secure cores. We're also having better plans in the future. They are EAL6+ rated by common criteria, so the maximum type of security you could find. Just to give you an idea, passports and credit card use EAL4 and 5 standards. Then we developed a firmware, and of course, being it installed on permanent hardware, it cannot really be open source for security reasons. It's audited by Kudelski Security. Mr. Jean-Pierre Omasson himself, who wrote Blake 2, is our auditor. And then that's open. Then the NFC protocol is open. All the NFC methods that you can use to interoperate with the Tangem cards are open. We also published some Android, iOS, and also some framework like capacitor SDKs, open source on GitHub. You can find them at github.com/Tangem. So any developer can really build applications based on Tangem, and we have a bunch of examples later. And then because of the full interoperable nature, because of the various signature schemes supported, any type of blockchain asset can be connected to a Tangem card. The way it works is, as I showed earlier, we basically took an existing a mechanism of private key and public key, and made sure that the private key is generated in a card and stays in a card for its whole life. So the full life cycle management of the key is contained within the secure chip here. Generation, safekeeping, signature provisioning, and deletion of the key. It's all done through NFC commands, and the private key can never get out of the card. Because of this, the only way to hold this key is to physically own the card, and the only way to present it is to tap it on an NFC terminal. So we made it super easy, even for grandma, to be able to verify, use blockchain assets of all sorts, and to transact. And that's why we're very happy that we have met PayID. We are also particularly proud to say that the integration only really took a week of time. It's just a matter of spinning up a server that is all pre-packaged and integrate the UI to create a PayID, assign it to a card, and to then receive the funds on that PayID. On the following slide, I explain how a few of our business partners have started to use this. We're very developer friendly, so we have these cards that we distribute on our shop.tangem.com that are for developers. So any one of you can just get this developer card and configure them on the fly to work with any type of blockchain, any type of asset, any type of signature scheme, any type of you can also set properties like PIN codes and security delays for security. And so we as Tangem want to be one component of a larger ecosystem for blockchain and let's say assets based on asymmetric cryptography. So moving forward, I have I can still see the chip to chain here. There's maybe a couple other slides, but it's not that important. The point is that we have a lot of developers that are starting to use this. Some for central bank type of real-time gross settlement applications. Some developers built their own wallets, like the Census one. It's interesting to say that when you tap this Census wallet card on a phone, it opens directly their wallet on the App Store. So it creates a whole contained experience for the wallet, and Tangem is just a building component. Just like PayID is the building component for the sending part, Tangem is the building component for the key management and holding part. Also, we see on the next slide, we see the Vault card. It's called Lobster Wallet. They built a multi-sig system. Again, they just use whatever NFC and SDK available on the market, and they integrated it in their application. And so PayID for us is just another little piece of utility that makes the whole holding, receiving, and sending crypto accessible. It's all about making it democratically accessible. And unfortunately, I must admit that in 2020, getting into crypto and transacting digital currencies is still behind a bit of a learning curve. So I cannot really expect my parents to start using it tomorrow. With PayID, we move one step closer to allow my parents to understand that sending ETH to Sergio just means Sergio.eth $PayID.tangem.com. Just like they've learned email, they will learn this as well. And I'll keep it short here. I see there's a few questions. I don't know if I should answer now, but I'd like to close this quick presentation by showing you how to send BTC to someone else, and also how to provision a new PayID on a Tangem card. So you receive your Tangem card, you type it on the phone. This one has already been preloaded with a balance. It has 0.029.
We stopped the presentation of slides so that the video is a little larger.
We go full screen for this. There you go. So I'll just repeat. A new scan, NFC. The phone is asking the chip to provide a proof of ownership of private keys. At this point, the chip will provide a signature. The phone will rest assured that this chip owns the private keys to this wallet address. Phone goes online on the ledger, checks, makes sure that the balance on this wallet is 0.029 BTC. I see that the PayID button is grayed out. It's because this card doesn't have a PayID address yet. I'll show you later how to add it. But first, I want to make a little donation. So I'll extract, and in the destination address, I'll paste, give directly at PayID.crypto, and I want to send 0.01 Bitcoin, not including fee, because I like them to receive a round number. When I verify this transaction, I'm going to be asked if I want to pay a higher or lesser fee, and then the way to send it is to press send, and again, the phone will ask chip for a signature. In the split of a second, the chip signed this transaction with the private key, and it was broadcasted on the network. So now the transaction is being broadcasted and pending confirmation. So I just donated 0.01 Bitcoin. And now, if I want, I can also add a PayID address to this card. I simply type it in. So I want this one to be, let's say, Sergio at payid.tangent.com. Create. Done. So if anyone wants to send me Bitcoin, they'll send it to Sergio, $payid.tangent.com, and I will receive it on this card. So in this case, this will be like a cash card. Only this card will own that wallet. And it can be given as gift, received, or it can be used for a closed loop payment system when and if merchants decide to accept directly payments, or when other wallets like Census and half a dozen other wallets enable the capability of accepting a Tangent inbound for payment. Thank you very much.
All right, thanks so much, Sergio. So one really powerful thing that might have been subtle there that I wanted to highlight, if you recall earlier in my charity demo I gave to Give Directly as well, I sent 10 testnet XRP in that case, which will be followed up by real value donation by Ripple corresponding to that amount. And Sergio here just sent the exact same PayID Bitcoin. And in fact, if you looked at the Give Directly PayID and you ran a query on it, you'd see that it has a number of different cryptocurrencies that it supports right now: Bitcoin, Ethereum, XRP, testnets, XRP, as well as a few others perhaps. And so you're getting not only the ease of use, but a single uniform interface into Give Directly or anyone else that you're paying. And so I think that's a really powerful concept here. You're fully abstracting the details away from the end user and making it super easy for them to move money where they want to.
Yeah, so easy is the right word. It has to be easy. As easy as an email.
Yep. So now we are, speaking of Give Directly, going to circle back to our wonderful charities that we are happy to support through payid.org/give. Please make sure to check that out and give money to some great causes. So we're going to now hear from Joe again at Give Directly. Hopefully no audio issues this time around. I still think I can't hear you. All right. Well, the demo gods are better to be unkind on the video chat than on the demos themselves. But Give Directly is a phenomenal organization, like the tagline here says, and the name implies you're able to send money directly, help alleviate poverty. So great cause there. Now I'm going to also turn it over here to Alpin at Mercy Corps, who is the fourth charity that you can contribute to through the charity app. And Mercy Corps is helping communities achieve prosperity, fighting through things like poverty and climate disaster. So over to you, Alpin.
Hey, Mike. Just wanted to make sure you can hear me before I start talking.
I got you.
Yeah, sorry that the person from Give Directly couldn't speak, but very supportive of the other NGOs and nonprofits and charities involved in this, and just want to say that we're really excited to be here and to be part of the PayID launch. For a quick background about Mercy Corps, so we focus our work across countries facing extreme conflict, disaster, climate change risks across every region of the world in over 40 countries. We provide direct cash aid, water and health infrastructure, food security, and access to markets, making sure that we're empowering people to ultimately reduce their dependence on aid. Last year, we provided support to over 29 million people. So what we're seeing at Mercy Corps is that even when we work with refugees from Syria or with even small businesses in rural Nigeria, people in very fragile conditions are better able to deal with crises and emergencies when they have access to financial assets and services. We know, though, that we live in an incredibly fragmented, uneven landscape for payments and financial services, and we see firsthand across the world that the current financial systems do not serve most of the world's poor. At least 2.5 billion people are underserved, including 1.7 billion that are flat out excluded. Mercy Corps is extremely inspired by cryptocurrency and blockchain innovations' capacity to serve the unbanked, whether that's lowering transaction costs, as well as bringing genuine interoperability across fragmented systems globally. And that's why we're so excited to be part of PayID's launch, as well as get to know a lot of the other companies in this ecosystem like Bread Wallet and Tangem. We're bringing innovations that are actually going to be very relevant to the people that we work with. Currently, we support basically all the new systems that are being built that we believe will democratize access. Mercy Corps runs pilots and trials with digital and crypto-based solutions for vulnerable populations, currently in several different countries, including Uganda, Kenya, and Colombia, which are ongoing. And we are members of the Libra Association, the Cello Alliance, and our venture arm, Mercy Corps Ventures, actively invests in early stage startups in the space. We see a lot of potential with the kinds of innovations coming out of Spring Labs Group and Ripple, and we're really thankful to be a part of this opportunity to meet all of you. And we would appreciate any donations from the people participating to Mercy Corps via the PID charity platform. And thanks.
All right, thanks so much. So, quick reminder, payid.org/give. Please check it out, learn about PayID, see how it works, while also giving to some really phenomenal causes here. So let's fast forward here, down in the deck, a few slides. So just to recap what we've actually seen so far, we've seen pretty much all the different standard payments that you or I might use in our day-to-day lives. These are push payments in a peer-to-peer context. These are poll payments, commerce context, subscription payments, potentially things like streaming payments, really exciting things, tangible things that are improving the end user experience and that are ultimately touching users. But when you think about a payment, there's a lot that also goes behind the scenes. And we live in a world where regulation is very prominent and becoming even more so by the day. One thing in the crypto space that is particularly pressing is the concept of travel rule. We're going to have a technical deep dive on travel rule where we'll explain a little bit more about it if you're unfamiliar. But suffice to say, the idea is that certain data needs to travel with transactions between regulated institutions. So this would occur between, say, a custodial wallet and a custodial wallet, something that's been the case in the traditional financial world for a number of years, but is increasingly becoming relevant in the crypto world. And so what we want to highlight here is how PayID can work behind the scenes once you have a secure channel of communication established between the sending and receiving wallets to enable the full scale or the full life cycle of a particular transaction. That includes things like compliance and travel rule information exchange. So that intro out of the way, we're going to have our friends over at CoinField. Reza is going to be presenting how they are using PayID to help solve some of these key issues for their business. Over to you, Reza.
Thanks, Michael. Hi, everyone. My name is Reza. I'm the CTO of the CoinField Exchange. CoinField is a crypto to fiat exchange based out of EU and is currently operating in more than 191 countries. As an exchange that's been operating for a few years, we understand some of the main pain points our users have, and integration with PayID could in fact solve many of these issues. It's almost impossible to expect users to memorize their long alphanumeric wallet addresses, and that results in clients mistakenly sending funds to invalid addresses, resulting in total loss of their funds or having to pay recovery fees. And we've seen many of that over the past few years in CoinField. Also, security-wise, it's not the best practice to log in to all the wallets on other exchanges only to obtain their addresses. One of the most important things for CoinField was the integration of PayID to comply with the FATF travel rules that came into effect in June, which is a requirement for exchanges in Europe. And by sharing the beneficiary and the originator information with the recipient, our exchange can comply with these regulations. And today we want to showcase how travel rule compliance feature on the PayID works on CoinField. Now let's go live with Garrett from CoinField as well to see a live demo on how PayID works on the CoinField Live website, as well as how the travel features are integrated. Thanks. I think, Garrett, you are mute.
There you go. Hello, everyone. Nice to meet everyone. My name is Garrett from CoinField, and today I am very excited to show you how PayID helps CoinField users to send and receive funds easily, and which complies with VAT travel rules. So the first thing I'm going to do is deposit Solo into my CoinField account. So here you can see I have my legacy address, the X address, and my PayID address. So right now I'm going to send funds to my CoinField account using my PayID. So I just sent the transfer over. And soon we should be seeing about 200 Solo arrive in my wallet. There you go. So the Solo just entered into my CoinField wallet. So right now I'm going to use the quick trade function to sell my Solo into XRP. There you go. So I just sold my Solo, and now I'm going to withdraw my XRP to another PayID wallet address. So here I'm going to withdraw about 4,000 XRP to the following PayID address, and then press submit. There you go. So now I'm just going to go to my email address and confirm the withdrawal. Awesome, and that's how you deposit and withdraw funds using PayID. Now I'm going to go to the back end. So since the withdrawal was over $1,000, we share the originator and beneficiary information with the recipient, which can be viewed on our backend here. So here you can see the originator information and the beneficiary information that was sent. So thank you very much for having us.
Awesome. Thanks so much, guys. So just to recap some of the important points there, certainly the user experience benefits, but these windows here are really demonstrating what's behind the scenes in any particular transaction. And we saw there a bunch of the fields that the two servers would be exchanging to satisfy data. But from a user experience perspective, it's actually really not impacting the end user, which is really important here. You don't want a compliance obligation to get in the way of user experience. With PayID, you can actually meet those obligations while providing an improvement in user experience. So the other thing to note, if you were quick enough, you might notice that the PayID that was used there very conveniently for the person running it was my own. Very conveniently saved the highest value transaction for the demo involving me. But I think that was actually testing XRP. But really cool to see this demo, guys.
Well, need mainnets, Michael.
Even better. All right. So a true travel rule compliance transaction. Fantastic. So that's it for live demos. Really great. Thanks to all of the demoers. Phenomenal to see how real companies are thinking about integrating this technology and how it can improve their applications and services. Before we move on to the next set of the program here, if we turn back to the slides, we want to just reiterate here, first two things. Please, again, donate at payid.org/give using Ripple's money. And then secondly, we want to encourage everyone to build alongside these companies. We are running a hackathon that Warren mentioned, kicking that off here. There are, I believe, $25,000 of prizes. I believe that will be kicking off now. So there's a ton of really great projects that we've already seen starting to kick off in the space here, but it's fully open to anyone. And please go to hackathon.payid.org if you're interested in joining. That will have the full instructions. There we go. Right there in front of you. Great. So we've sort of seen here, just to recap, the full gamut of payment types. These are things that you and I would be familiar with here. But we want to move on now to entirely new user experiences, things that aren't even done today, and how PayID can help enable these really cool applications and services that involve value and users. So one thing that is really a core principle and core space that PayID operates in is the world of digital identity. It's a very limited extent to which PayID operates, but it also works nicely with a ton of other identifiers and really any protocol at all. So I want to turn it over next here to Kevin at Rally, who's going to explore how PayID and the idea of verifiable ID in general works and is important in a social world. So over to you, Kevin.
Hey, thank you. Great. Well, thank you for having me here. I'm very excited about PayID, and just it's amazing seeing all of these integrations and demos live. So very cool stuff. So Rally. So my name is Kevin Chu. I'm CEO of a project called Rally. It's a project where we tokenize creators and people in general. If you haven't heard of it, don't worry. We've been heads down building this for the last year and a half, and we're about to launch in the coming weeks. But I'm even more excited about talking about PayID today and some of the things that we see as really important use cases as we think about our project world, where social media is pretty prevalent. So Rally is planning to use PayID to help creators all over the world get paid by their fans and by sponsors. And I'll talk a little bit more about that. But really our work with PayID is to work with the community on how to create additional trust payments, around some, big name people and some of the common scams that, or attack vectors that we see happening in payments even today. So that's what I plan to talk about. If you go to the next slide, please. The slide after that, please. So I'll just touch on 3 quick things today. I'll give a very brief project background for Rally, and then I'll talk about where the use cases where social ID and verified ID are going to be really important, and then just outline the problem space that we're hoping to work with the community to solve as hopefully millions of people around the world start adopting this new protocol for payments. Okay, next slide, please. So quick background, Rally is a project where the team is a lot of different gamers. My background is I founded a company called Kabam. We made games for 11 years. I was fortunate enough to have 500 million people play Kabam games over the years. Sold that company in 2017. Some of the key members of the team went over to Twitch, and I worked at Twitch for a number of years. Others, including myself, went to start an esports company called Gen G, where we have professional video gamers all over the world. And then we all kind of came back together to start the Rally project and got really excited about what was happening in the blockchain space about a year and a half ago. Next slide, please. So the genesis of Rally was a game that launched in 2014 called Kim Kardashian Hollywood. And this game wasn't the gameplay itself and the graphics wasn't anything special. What was unique, it was just a game about one person, and really kind of living your life as if you were sort of a friend of Kim Kardashian. And if you go to the next slide, what was really unique about this game was that it seamlessly blended tweeting out to social media as you were playing the game itself. And it made it so seamless that, people on accident would tweet out. So, for example, this was a funny screenshot by a government official of the U.S. EPA who was playing this game and accidentally tweeted out to the verified account for the for the EPA. This game actually hit almost 10 million players in just 48 hours because we're just so viral. It literally blew up and took over Twitter, for about 48 hours, and took kind of the gaming world by storm. And if you go to the next slide, it also made quite a bit of money. So this is Kim Kardashian actually tweeting out, this is about a year and a half in, that she was cashing a check for $80 million. The game had made $300 million. And, after App Store payments and so forth, this was her kind of take home. So a lot of money in this stuff. And if you go to the next slide, that was kind of, that plus, I've been thinking about these types of games, and kind of the social interactions, surrounding them for quite a while. And then as I started to think really deeply about the blockchain space and getting incredibly excited here, I really wanted to bring these two worlds together. So I asked myself, what would happen if you could make a game that was played out across social media? What if you could level up and you could create and collect virtual assets, virtual currencies, by engaging with other people, especially with these big creators and influencers. And so today Rally isn't a game per se, but we use a lot of these kind of basically taking blockchain primitives and combining it with a lot of our experience designing games and thinking about social media at Twitch to basically create the Rally project. And again, hopefully we're launching in a few weeks. And but I want to give some background as to why we've been thinking about payments. I'll go into that in a little bit, and specifically identity and verification. So if you go to the next slide, social media today, there's already a lot of payments, so flowing through social media, right? So what you see on this slide is people making some pretty large payments, 6-figure, 5-figure payments. These are being sent from a fan to a streamer live, on Twitch. So a lot of these types of payments are already happening, and that's part of what we're excited by. If you go to the next slide, Rally, we're working with a bunch of Twitch streamers, but we're also working with musicians and UFC fighters, and just a bunch of creators and artists trying to make a living, and especially affected by COVID today, and pretty excited about the launch soon. If you go to the next slide. So I want to move on to talk about why social ID and verification, especially as we see a world where PayID makes it easier and easier to connect all these disparate, both fiat as well as crypto networks or payments systems bases. Will be an increasing problem. So let me share a couple of stories first. Actually, if you go to the next slide, I want everyone to think just a couple seconds on what is the most visible space in the digital world today. And of course, if you go to the next slide, that is, social media. Today, 2.5 billion people are using Facebook and WhatsApp and Messenger and WeChat and Reddit and Twitter and so forth. And this becomes a really interesting area for payment. So if you go to the next slide, so we go back to our Twitch example here. I'm sure a lot of you probably picked up these payments. The reason why these payments are happening on the social media environment is that you can see the reaction from the creator itself, but also just as importantly that it's a broad social space. So there's in some of these cases tens of thousands of people watching this type of stream live, and so the person making the payment is able to get in front of a lot of different eyeballs, and that recognition and that community online is an important part of why payments and social represent a very unique field. If you go to the next slide, but there's some problems with this. So social media, of course, has always had a problem with identity. If you go to the next slide, please. And so going back, that's our previous slide to this one. That slide, perfect. So going back to our Kim Kardashian example, Kim Kardashian, she actually joined Twitter a little bit late, although she was one of the early big celebrities to join on. So this is her for one of her first tweets. Hey guys, it's Kim Kardashian, following here on Twitter, but there's already a bunch of fakes. So we know this is obviously a clear problem across social media, that there are fake social accounts. And if you go to the next slide, and this becomes a really vulnerable attack vector for thieves and scammers online. Last year, actually, earlier this year, the FTC was investigating a number of different complaints about fake celebrity accounts across all different types of social media, and they reported about $328 million of filed, claims against people in the United States being scammed out of money by these fake celebrity accounts. And on the right side, you can see some of the, there's some pretty sophisticated stuff. So on the right side is a Twitch account, and what this scammer has done is basically taken a very famous Twitch celebrity called Shroud. They recorded hours and hours of this person's stream, created a fake account that sounded like Shroud's actual account name, but had a few letters off. And then they they basically replayed hours and hours of prior footage from a while ago, and then overlaid across the stream a bunch of different ways that you could give money to Shroud, and he would give back money to you, etc. And of course, this was all scammers and thieves that were trying to do this. If you go to the next slide, take our favorite tech celebrity here, Elon Musk. Actually, just last week, he was in the headlines, or really his identity was in the headlines in terms of people had scammed out $2 million of BTC by using vanity addresses. And so, and of course, this isn't the first time that that Elon Musk has kind of been in that. A couple of years ago, somebody bought a verified account on Twitter that somebody sold off, ran an created a scam on Twitter, and then promoted that tweet and scammed quite a bit of people out of some money just a couple of years ago. Down on the right side here. If you go to the next slide, this is just showing some of the vanity BTC wallet addresses that were used. Apologies that the text is a little bit small, but you can kind of see, on the right side, there's kind of the leftmost column says short, and you can see sort of some of the early, the early string in that field that people are basically using Elon Musk. And this is just very simple, sort of a social media account. Hey, send me, BTC. I'm giving away, if you send me, a little bit of BTC, I'm going to give away 5,000 BTC to a lucky winner, and send money, send BTC to this address. But of course, we can imagine with a lot of what we're trying to solve with PayID in terms of making a human readable payment address, that you can imagine Elon.Musk and $ example that these types of attack vectors will be something that we all need to think about. If you go to the next slide, so then as we think about working with a lot of these creators, we're really interested in, of course, collaborating with the community here at PayID to kind of think about different possible solution sets. If you go to the next slide, there's three main things that we want to guard against: fusion, impersonation, right? And I think these are not problems that are unique in the blockchain and crypto space. These are problems that have plagued the internet and have had really smart solutions. And so if we go to the next slide here, I'm not proposing any specific answers, just yet, but again, hoping to work with the community. We kind of think about it as there's if you go along the y-axis here, there's verified ID, which is, okay, is this person's legal name really Elon Musk? Do they have a government issued ID? Here's a tax ID. This person lives in this address, etc. And this person has no sanctions, against this person. Great, that's verified ID. Verified social ID is when we think of an Elon Musk. Is it the Elon Musk that we would all think about in terms of, again, their social presence online today and the tens of millions of followers that some of these big name celebrities have. on the sort of x-axis here, certificate authorities, right? So we can imagine that the social networks themselves over time, financial institutions, like a lot of ones that are already interested in PayID, as well as new ones coming up, these are going to be more like, how do we use some of what's worked in the past around certificate authorities and add in, adjunct fields and ways to pass information through PayID. And the second, of course, is things that how do we create more trustless forms of proof that are community-driven and community-accepted. And I think if we think about an overall payment network that becomes more and more robust and powerful over time, in creating some of these network effects where payments are incredibly strong, we think there will be kind of different forms and different actors that join the network, and we want to make sure it works for everyone and everyone benefits. And so we're not strongly opinion about how, on trustless or certificate or how what kind of authorities are allowed. We're interested in making sure that the framework that is established can help with solving some of the problems that I think we're going to face and see. So if we're able to do that, we'll go to the next slide here. What this looks like is how do we think about creating the equivalent of that blue check mark, but in a payment space, right? So we've been sort of the Web 2 has been about, eyeballs, bringing people online, but a lot of that's been monetized through ads. And so a lot of the verified, problem space has been around social media and that identity, but as hopefully we live in a world going forward where payments become more and more interwoven into the fabric of the internet. How do we start thinking about payments and payment IDs as in establishing the right trust for everyone in the network? And so finally, my last slide here, if you go to the next slide, there's a lot of network effect benefits of this. Obviously, I'm not trying to be exhaustive here, but obviously the first one is that even if Rally sees a user for the first time, and we can see that there's been a kind of nice payment history. Obviously, prior verification will help everyone in the network reestablish these types of data fields, and so helps everyone in the network. And from a creator perspective or from an individual person perspective, having network-wide adoption prevents a single actor from dispossessing a person of their online identity, especially a financial identity. And I think that's really important, especially in countries where there are more authoritarian governments, and especially ones that want to very tightly clamp down on financial, payments. So these are things that we're pretty excited that PayID, in a network, an open and shared protocol like PayID, offers a long-term solution to this, and we're very interested in working with the community to solve these problems. Go to the next slide. Yeah, I think that's it, and thank you for everyone's time, and we look forward to working with others that are interested in this problem space. Thank you very much. I'll turn it back to you, Michael.
Great, thanks so much. This is actually headed over to Warren.
Yeah, thanks a lot, Kevin. It's great to have Kevin on board. He's obviously a prolific entrepreneur, so a grand vision for social identity. At this time, I actually wanted to address some of the questions that came in the Blue Jeans chat. So there's a way to actually like questions as they come in. So there have been questions that have kind of bubbled up to the top. And I know Ethan Beard, our SVP of Spring, and Jen Yu, our VP of Growth, had been awesome answering some of the bigger questions. But just kind of going over just a few to highlight. The first one, are there any banks deploying PayID right now? That was the top question. And it's important to remember that PayID is an open standard, so it's really hard to know what people are doing with it. It's permissionless and can be adopted really by anyone. However, Signum Bank is one of the founding members of the Open Payments Coalition supporting PayID, so we're really happy to see such an innovative bank adopt so early. So there's a question about, obviously about tutorials. There's lots of tutorials online. You can find them on docs.payid.org. There's quite a few ways to deploy PayID, so you can get we'll address that more in a little bit, talking to the partner engineers. So video conferences will be available after the conference finishes. Give us some time to get those live. We'll be sure to announce those. You can play them back and share them with your friends as well. Let's see. How do I use PayID in standard ACH transactions for low-cost, faster payments? So, it's important to know that PayID doesn't speed up ACH transactions or actually any of the underlying transactions. Because PayID sits on top, it's an addressing layer, it still relies on the underlying settlement networks. So we hope that PayID, though, will usher in new innovation into the space that will help the underlying payment networks innovate a little bit stronger. So let's see. Can you elaborate on how will XRP be used within the PayID standard? Like I said, PayID works on any different payment network. XRP is an existing payment network. It's quite fast. It works very nicely with XRP, but it also works with Bitcoin, Ethereum, and other cryptocurrencies, as well as traditional financial networks. That's why we're excited about PayID, is because we think that PayID is one of the first chances to actually bridge the crypto and traditional financial worlds. So I'll just scroll through a few more. And then I want to save a lot of the technical questions for our deep dive session, which is coming up next. Remember that this is a developer conference for developers, so we want to make sure that we are addressing those technical questions. And there's quite a few. A lot of them are buried at the end. So if you want to go ahead and upvote those to get them at the top, so we can have them more visible for the team, that'd be awesome. Who designed the PayID logo, and what's the inspiration story behind it? So, Ripple's fortunate to have an amazing cross-functional, talent of teams. We have an amazing design team, and there is a good story about the logo, which we'll probably follow up on in a blog post. But it's really been inspirational to see the design team work and all the teams come together. Working with the coalition of 40 companies, you can imagine the amount of communication channels going on. So for it to actually come into existence so quickly was really remarkable. So that's it. I think I want to transfer it over to Josh Williams, who is the CEO of Forte. So we're really excited about Forte. Spring was an investor, and they are building out a network for gamers to do more of a virtual economy. So Josh, good to have you on.
Thanks so much, Warren. We're really excited to be here. Really excited about PayID. I'm going to walk through some of what Forte is doing and how we're using PayID, and we also have a demo of PayID in action to enable some of the stuff we'll talk about quickly here. So as Warren said, I'm Josh. I'm with Forte, and if you go to the next slide, what we're trying to do at Forte is to create new economic and creative opportunity for billions of people around the world through games. Today, games are played by over 3 billion people every month. People spend a lot of time, a lot of effort, and a lot of money in games. It's about $160 billion a year revenue industry already today. And what we're really trying to do, if you move to the next slide, is create new economic opportunities in games by allowing players to own digital goods and currencies inside of games, which they already purchase today but don't own, and then to enable players to buy, sell, trade digital goods and services in games with each other, and through doing that potentially earn income through their play, so that you can purchase a good and sell it to another user, or perform a service for a player. And millions of players do this already today. It's just a very high friction experience in the world today, and we're trying to make that easier. Through doing that, we're also opening up new business models and economic opportunities for developers as well, so that developers can shift from thinking about how much money they can extract from players, and instead think about how can they create the most thriving player-to-player economy through the virtual world in their games, and really make it possible for players to earn more income. And the better job a developer does with that, the bigger their economy becomes, and the more developers can benefit too. So that's what we're trying to do. And we're also pulling in creators and fans from around games, where streamers help drive adoption of games and popularize games. And if you look at the top games in the world today, like Fortnite or Minecraft and many, many others, a lot of their growth was driven on users really talking about the games online, even streaming games as they play it. And so can we create economic models where developers and players can pay each other? In order to do that, you need a frictionless payment system. If you go to the next slide, what we're really about is, if we think about all the things we're trying to do and enabling a player-to-player economy and new business models for developers and for creators around games, we're trying to take these vibrant communities inside of games and really create a true economy around those communities. We call it community economics, and core to doing that, if you move to the next slide, is making it really easy for players to send payments to each other, to transfer value, within a game and even across games, between and amongst each other. In order to do that and to create the most trust in the biggest potential market, you really need a free and open system that players know they can rely on. It isn't dependent on any one developer or any one operator, including Forte or anyone else in the world, that players truly own and can participate in fully. And it also needs to be interoperable. You can't, it won't be as big as it could be if each game kind of stands on its own siloed world, or if people are totally dependent on a single developer. So the system needs to be interoperable, it needs to be free and open, and it needs to be easy to use in order for developers to adopt it and for players to understand it. So that's why we're so excited about PayID. If you go to the next slide, today there's just a ton of friction in the blockchain world. If you own cryptocurrencies or tokenized assets, they're difficult to use from an end user perspective. Game developers and game players are accustomed to just being able to tap a button and complete a purchase, and we really need to provide a seamless experience. It also needs to operate at scale. Individual games have hundreds of millions of players a day, so just massive levels of scale. And so in order to make that work at the scale of games today, we need a new system that doesn't rely solely on individual blockchain payment networks, but spans all the payment networks in the world across blockchains and fiat currencies and the like, and just make it seamless for players from anywhere in the world to send payments from one place to another and cross borders, cross currencies, as they need. So there just has been a lack of the basic tools to enable that to date. But systems like PayID are, coming to the fore now, and we're really excited about it. And pulling them into games, making it easy for developers to adopt it inside of games. If you move to the next slide, we just wanted to walk through, again, it's critical in order for developers to trust a system, and ultimately for players to trust a system, that the networks they use and rely on for payments are truly open, that they are secure, and that no individual owns them. So it needs to be a community-centric platform, an open network that is accessible and inclusive to anyone that wants to join it, any developer that wants to use it, and it can use the same standard in the same way that that all games incorporate multiplayer functionality using internet protocol, and we want to enable the same simplicity for enabling the internet of value and payments between and across players. And on the next slide, if we look at why, there's a very wide spectrum of use cases that players can do in-game, if we could really enable frictionless payments between players. There's a game called Animal Crossing New Horizons now. Maybe some of you have played. It's a really popular game. It broke some sales records for Nintendo. And in the game, even though it's largely a single-player game, you can visit in the game. You can move. You as a player have an individual island, and you can move from your island to another player's island, and you can conduct in-game commerce with each other, but there's no way to cash out in the system. And so what people have done on Reddit and elsewhere is created basically little businesses around this game, where one of the activities in the game that you have to do in order to make your island nice to look at and also more productive for the in-game economy is you have to weed. You have to pull weeds in the game, and it's kind of a tedious task, but it's part of what you're supposed to do in the game. And so people created a little business around offering a weed pulling service, basically a gardening service in this virtual world where you can go to Reddit and basically ask for help with your island and potentially trade or make payments for people. But it's an extremely high friction experience because you have to know about this service that exists, go outside of the game, potentially make a payment for it. And the same thing happens with trading of goods inside the games. And in fact, not just Animal Crossing, every major game ends up with these basically economies where players are trying to connect with each other and just don't have a low friction means of doing it. So we're really trying to enable that and make it easy for developers to integrate this stuff and design really compelling systems around it that are embedded inside of games and can access again the billions of people that play games all the time. On the next slide, we'll talk a little bit about PayID. We announced our support for PayID. We're integrating it into our platform at Forte, which again is designed to make this stuff easier for developers to integrate. And on the next slide, what we're trying to work with developers to do is make it possible for players to receive rewards for the contributions they make in the game, to earn income from games, and ultimately for developers to have new business models. So you can do things like, if you played a game like World of Warcraft, for example, you might have been a player that really wanted to access the top tier content, like the most difficult content in the game, but it might take more time than you have because you're busy with work to be able to go access the content, or you may not have had access to the most elite guilds or groups of players in the game world to get there. But you can imagine a system where it might be possible to hire a guide to take you through some of the content in the game. Maybe a player who's very experienced and has done all of the most difficult content, is willing to show you around, and you might want to send them a tip to say thank you for showing you this content that you've been dying to play for a long time. There's just millions of examples of those types of possibilities inside of game worlds today, and even more that even we can't imagine yet, as you really think about how to enable payments between and amongst players. And in games where players spend billions of hours in games today. Epic Games, which is the developer of Fortnite, one of the biggest games in the world, announced a few months ago that players spend 3.2 billion hours I think a month in just Fortnite, right? So players are spending just a tremendous amount of time in these game worlds, and want to make it possible for them to really own the goods that they purchase in these games, and to create a thriving economy amongst players in the games. So on the next slide, really, sorry, if we move to the next slide, yeah, thank you. You really need a payment system in order to tie all of this together. In order for players to earn income, for fans and creators to earn rewards for contributions inside of a game, whether that's exposing the game to more audience and pulling more players in, or creating helpful guides and how to plays, or guiding players through difficult content like we discussed. And in order for developers to see benefit from enabling these types of systems, and for them to benefit from, potentially all of the transactions and payments and micropayments that are flowing back and forth between players. You need a payment system to enable that. And for developers and players to actually get paid for their work. And again, recognizing that games are truly global. People from all over the world in different countries, use different fiat or native currencies, play these games and want to be able to transact with each other. You need a system that can easily hop from point to point and across borders and from currency to currency. And so it needs to be an open, interoperable system that can span really any payment network. And so we really love the design of PayID. And if you go to the next slide, the fact that, thank you. The fact that, it makes the user experience very simple for both developers and for players inside a game. So instead of having to memorize long public keys or unique account numbers, and instead of having to think about, how I'm going to send a payment, maybe, for me as a user in the United States who wants to make a payment, maybe with a credit card, to someone who might be in, Brazil, how instead by the player in the game I'd like to send a payment to and just have it work. Just in the same way we can play with each other in the game and be exchanging data constantly, we should be able to exchange payments and make it just as frictionless. And finally, because there is value involved, we need to make sure, and developers who create these games and run real businesses need to ensure that the transactions that happen between players are compliant with international rules around money laundering and the travel rule, as we discussed earlier in the conference here. So it's all very difficult to get right, and PayID makes it easier for developers to really just implement solutions and not have to worry about all the plumbing under the hood, and that's part of what we try to help with as well. And because there are incompatible payment networks and a lot of friction in the way payment systems work today, PayID really makes it possible to integrate this seamlessly, and we'll see that in a minute with a demo. So on a final slide here, our goal is really to make it easy for developers to integrate PayID inside of games, to create open and free payment systems between and amongst players anywhere in the world, to make these systems interoperable across games, across payment networks, and ultimately to open up more opportunity for both developers and players. We're really excited about it. It would not be possible to do this without PayID or something exactly like it, and so we're really, really excited about it. Chris is going to show a quick demo of what PayID can look like inside of games, and how this can kind of bridge things together as players work together inside of a game community. So Chris Jimison's our head of engineering at Forte, and take it away, Chris.
Hey, thanks, Josh. Appreciate it. So this demo, and this is just a quick demo that we kind of put together when we were exploring and integrating PayID, was really kind of around the idea of we wish that we could play some of these big, rich, deep in-game content that typically requires a lot of hours and a big group of players. World of Warcraft, I think, is the perfect example. And, a colleague and I were kind of lamenting that spending all this time to build up that community credibility and engage in all this content becomes a full-time job. Well, why can't you just get paid for it like a full-time job, or at least get some value out of that? So we thought, well, great, what if we put together a demo of actually having a jobs posting board where people can actually submit work to be done in their game, and then have guilds that they can connect with show up. So I'm going to go ahead and share my screen here. So this is our little PayID demo, and it's just basically a jobs posting board where you can go in, list work that you'd like to have done, what you're looking for, how much you're willing to pay to do this job. But PayID is really interesting because we could take concept of an actual user address, but apply it to more meta concepts such as a guild or an actual game. So what we set up is we got a series of games that we've created. Each game can have essentially like a rev split, saying whenever a work is done, I want to receive so much money. And they can have a very easy to see and understand address. as well as guilds too. So I can have a guild that has a bunch of players attached to it that can get paid out at certain percentage rates on their guild points. But then they can also have a PayID. So let's just kind of jump into the demo here. So here I have Chris, and Chris doesn't have a whole lot of XRP right now. He needs a little bit more, and this is his PayID. We'll go ahead and jump over to the Spring testnet. Let's go ahead and give Chris a couple of extra 100 XRP. So using PayID, this transfer is going to go through. Come over here, we can check our balances now. And we have some more currencies. And that's how easy it was to kind of preload your account in this case with this currency. More importantly, as I'm playing the game, maybe I had some help from the guild, the Cool Kids, which we saw over here. They reached out, they saw my job posting board saying, hey, I need some help with Heroes of Destiny. We went ahead, we played the game, had a good time, and I want to go ahead and pay them out. So here I'll go ahead and we completed the operation, so I'm going to go ahead and pay Cool Kids. Oh, I don't actually have enough currency. We'll do the confirm instead. This is going to go ahead and make an XRP payment to that guild, but it's also going to go ahead and take a slice of that and pay it off to the game publisher that owns this game, Heroes of Destiny. It takes a little bit more time because it's going through and making multiple payments. But once it's completed, I can now come back and see that Cool Kids actually got their currency bump, but the game itself also now has some additional currency inside of it. It got an extra 120, or it got an extra 20 currency based on the rev split. But finally, as a game developer, I may say, great, I've made some money, I want to go ahead and transfer some of those funds out. I can easily go through or take my account, make a payment to my Chris at Spring account. Go ahead and give me 50 XRP back. Now I'm draining money out of this system. And come back to here. And I can see that this transaction was actually received from the player exchange. And that's basically the demo. You can still also inside the demo, this is an open demo, anybody can go to devplayerexchange.io. You can also pay out the guild members. Like I said, I won't do that because that takes a little bit of time because it goes through and it sums up all these different guild points and then pays out a percentage based upon your total number of points. But yeah, we really are very excited by this because, again, it's much easier for me whether I'm chatting in game or if there's actual integration components to say, hey, my guild name is the Cool Kids. It's not X743228 and then potentially run into issues of, did I pay the right person? There's more trust from the individual, and also there's more trust if I wanted to actually pay the game developers or the publishers to unlock other components. Thank you so much. I'll hand it back to Warren.
Thanks, Chris. Appreciate the demo. You guys built some really cool stuff. So I want to turn it over to Anshul, who is our leading security engineer at Ripple. Also one of the authors of PayID. He's been an instrumental force in making sure that PayID uses existing security standards. So Anshul, if you're with us, go ahead and join.
Hey, can you guys hear me?
Yes, loud and clear.
All right, so thank you, Warren, for the introduction, and hello, everyone. So sometime back, Michael gave a very good technical overview of how basic PayID protocol works. Now I'm going to talk about the motivation behind the design of PayID protocol and its extensions. And more specifically, I'll talk about the security and privacy guarantees, the strong security and privacy guarantees that PayID protocol provides. Next slide, please. So the first, I'm going to talk about the design principles behind PayID. So the first is the extensibility. The basic PayID protocol is designed in a way that it is easily extensible to a number of use cases. For example, one of the works in progress is to enable sending and receiving cryptographically signed proofs of payments and receipts of payments alongside the payment information. For example, and this could be useful in case of making commercial or charitable transactions. Second, it's extensible even further to include a standard for secure messaging that can, for example, be used by covered institutions, that is, the institutions that must comply with some set of regulations to fulfill their compliance requirements, and travel rule being the most topical example here. Another design principle behind PayID is to make sure that it is composable. So PayID's simple architecture and tried and tested web stack makes it easily composed with existing namespaces and other standards. So PayID can easily wrap blockchain namespaces of the likes of Ethereum name service or unstoppable domains, or service-specific identifiers like cash tags or Coinbase usernames. And on top of it, it provides each of them far greater reach and user value. And third, last and not the least, among other things, as I always emphasize that here at Ripple, we realize that we are designing protocols and building products that facilitate free movement of real money. And we tend to take this responsibility seriously and prioritize the security and privacy as a requirement and not just as an option or an additional feature. As a result, we have invested considerable time and effort on getting the security and privacy model right while designing the PayID protocol. So basic PayID protocol ensures that all user and app data stays private from third parties by encapsulating all the PayID protocol messages in HTTP over TLS. And we recommend using TLS 1.3 with elliptic curve cryptography to make sure that the protocol implementation is efficient without having to trade off security and privacy. So basic PayID protocol provides confidentiality with end-to-end encryption of data. It provides mutual authentication for the participating entities. And third, we made another cryptographic choice is to use ephemeral Diffie-Hellman key exchange to make sure that for each session, a different symmetric key is established. And that's what makes PayID protocol perfectly forward secure, meaning that if either party's present keys are compromised, it does not compromise the data that is encrypted in the past because each session has different keys. So that's about the design principles and the security of basic PayID protocol. Next slide, please. And this is a pretty sophisticated model for privacy and security from third parties. But we want more. We want PayID to support zero trust model for the participating entities. And that's a challenge. So what do we have now? Right now in basic version of PayID, there are several trust relationships between the participating entities. First, the sender can be sure that the response from the PayID server has not been modified in flight thanks to the underlying transport security, but the PayID server still has full control over the contents of the response message and may go rogue or be compromised. The sender has no way of knowing if the PayID server behaves maliciously. This implicit trust assumption between the sender and the PayID server is not really ideal in the world where the information provided by the PayID server may be used by the sender to transmit money. Second trust assumption is in cases where it's necessary for the sender to interact with the owner of the on-ledger keys. For example, in case of compliance for transferring data, they need to be sure that the counterparty actually owns that private keys to the payment address that they provide. And the sender is not sending, payments or the sensitive personal information to wrong entities. And third trust assumption is between the receiver and their PayID provider to provide the correct PayID to payment address mapping. Now, this might not be a big deal for custodial service providers because there is an implicit trust relationship between the receiver and their PayID service provider, but it does matter for non-custodial service providers. Next slide, please. So how do we solve this? Our solution to eliminate or to minimize these trust assumptions is what we call verifiable PayID. Verifiable verifiable PID, a zero trust model. So the idea here is to include A, third-party verifiable cryptographic signatures to the responses, and B, to include pointers to external digital entities of the signer that associates to the public keys of the signer that can be used for verification. Next slide, please. So how do we frame verifiable PID trust model? Now, on the previous slide, I talked about generating signed mappings and other cryptographic proofs with digital signatures. But who is the signing entity? Now, different service providers have different trust relationships with their customers. For example, for custodial wallets, there is an implicit trust relationship between the wallet and their customers, and this is for obvious reasons that the wallet holds their private key and hence their funds. In such a case, these wallets can be custodial PID servers, that is, the mappings can be signed with the PID private key of the custodial wallet. And PID protocol does not require any additional trust between the custodial PID service providers and their customers. On the other hand, non-custodial wallets operate in a different trust model, where the customers do not have to trust their wallets because the customers themselves hold their private keys. Such wallets would want to be something like non-custodial PID service provider. In such a case, what we would ideally want is to have these mappings signed by the customers or the clients on their device. This is to say that even if the wallet server goes rogue or is compromised, an attacker cannot swap these mappings because they cannot get hold of the private keys of the receiver. It frees the non-custodial wallets or service providers from any additional liability. Next slide, please. Now, to answer the question that I raised on the previous slide, that is, who would sign these keys or who would sign these responses, we can say that for custodial wallets, it's reasonable that PID servers are comfortable enough to use their web certificates to sign the responses and make them non-repudiable. Additionally, to prove that they actually own the private key corresponding to the provided payment address, they can sign this address with their on-ledger public key, private key, to provide a proof of control of address. So we have these provisions in the verifiable PID protocol. For non-custodial service providers, on the other hand, since the receiver or the beneficiary of the payment is supposed to sign these mappings, this PayID to payment address mappings, it's slightly more trickier on how to distribute their public keys. Put in other words, we need some sort of digital identity solutions, which some of our partners touched upon in the previous talks, for the receiver that can associate their identity to their PID and or their public keys that can be verified and that can be used for the verification of these signatures. And in my opinion, this is one of the most challenging and interesting open question in verifiable PID, and we require your input and feedback on this. Next slide, please. Having said that, we have come up with some of the options that we think can be used that you can use for users, that can be used for retrieving, distributing, and verifying user's public key, that is the receiver's public key, who are signing these mappings. So one of the solutions that you can think of is to leverage identity solutions used by existing consumer messaging protocols. One of the most popular being the Signal protocol, which is also used in WhatsApp messaging. As we all know, that it's an end-to-end encrypted protocol with several salient cryptographic security and privacy guarantees. We do not really need to implement the entire complex suite of Signal protocol. Rather, we can use some customized version of it for generating and distributing the identity keys of the clients. PID servers can distribute the identity keys of the PID owners, which can be uploaded by the key owners on the PID servers. Now, don't get confused here. It still would not require any trust between the client who's uploading the keys to the PID server And that's because Signal Protocol actually suggests to match the public key fingerprints received from the server or with the other party out of band, or go for a trust on first use approach. And that's how Signal works. And there is a huge user base who trusts Signal, and it has worked really well in terms of security and privacy. So this could be one option. Another option is to leverage existing PKI system, existing public infrastructure systems, which could be a centralized web PKI. The owner of the PayID, that is the user, may use their web PKI key to sign these mappings and store them on the PayID server, along with the chain of certificates. The receiving side receives this mapping along with the certificates and can use them to verify the signature on this mapping. There are some caveats to this approach. As we all know, it requires trusted third parties, it's centralized, single point of failure, it's an attractive target of attack, and certificate revocation is broken. Another option is to use decentralized PKI, that is to use something like pretty good privacy PGP keys, Web of Trust, or Open PGP certificates. Works similar to how the web PKI works. The PayID owner may use their PGP key to sign these mappings and then upload them to the server along with their certificate, which can then be served by the server to the receiving side. Although this is a little better than maybe a centralized web PKI, it has a distributed trust model. It's not very widely deployed because it's not user-friendly. We know that it's hard for the initial or remote users to join because you might have to go with these key signing parties to get your Open PGP certificate from trusted peers. Then we have blockchain-based PKI, which is again a decentralized, which is based on decentralized and distributed trust. And we have recently seen a lot of proposals in this space, which come in two different flavors. One where attestation of the identity is off-chain, and the identity data, or with more private approaches, you can say identifiers for this identity data, are stored and can be looked up on the blockchain. And the second approach for some of the proposals are purely blockchain-based and use consensus protocol for on-chain identity attestation. Pretty interesting space. I would be curious to hear if someone is thinking about identity solutions in this space. So these are the two options. Another option is really interesting too. So linking to other external digital identifiers, something like a global digital identifier that can uniquely associate the PayID owner's identity, whatever that identity means, as defined by some of these identifiers that I have on this slide, such as Global ID, DID Alliance, or Human Universally Unique Identifier, to the PayID. So associate the PayID owner's identity to the PayID and the public key. The PayID client can then verify this public key and ultimately the signatures using this digital identifier. Again, as Kevin touched upon this in his talk, this could be a direct retrieval of the corresponding public key from a digital identity service provider. If PayID, let's say, is a part of that digital identifier, or one can have something like certificate issuance, certificate authorities that can provide an attested certificate that would associate digital identifiers such as these to the PayID and public key. So this is like a high-level idea, and we are still working on these ideas. We would be really curious to hear how people feel about which is the best solution for verifiable PayID. Next slide, please. Now the next question is how these signatures are incorporated in the PayID protocol. So in terms of implementation, it's pretty straightforward to incorporate any kind of identity solution in PayID protocol. So in the PayID server response, we can have these mappings signed with the public key of whichever identity solution we choose. These mappings can be signed either by the PayID servers or by the PayID owners to support different use cases and security models. And on top of that, we can optionally add signatures to prove the ownership of on-ledger keys. Now, the bottom line here is that integrating any solution that we think is best for our use case is very straightforward, thanks to the flexibility and extensibility of the PayID protocol. The hard part, I think, here is to choose which option do we want to go for, to choose the root of trust, to choose the identity solution. That's a good trade-off between security and usability. And that will be all. Next slide, please. I'm not receiving the video, but yeah, you can be a part of an ongoing discussion. We have these RFCs. It's an open source, and we'll also be organizing working security and identity working group sessions. We'll be meeting regularly. As I said, we would love to hear your ideas on how we can make this protocol more secure and robust. And with this, I'll hand over the mic to Warren. Thanks, everyone.
Thanks, Anshul. I know we're running about 5 minutes behind, but I want to make sure that we had, that I raised a few questions for Anshul that kind of bubbled up in the chat. Anshul, so there's been a question about and concern about like domain expiration. I've like personally, owned domains where I forgot to, have them renew. What happens if, a domain expires and you actually lose access to the domain?
So the question is that what happens if the domain under which my PayID is registered expires or is transferred?
Yeah, or if you just lose access to the DNS records in any way, like what are some of the kind of things you can do? I guess we do not have any good way of actually revoking the PayIDs if the domain is revoked. It's, I guess, the similar situation if the domain is revoked. What do you do? But in case of PayID, I guess since the PayID maps to the underlying payment addresses, and I think the only way would be to just change these mappings. I mean, making sure how the domains are unique is a part of the registrar from where you are getting the domains. They should make sure that the domains are unique and are not compromised. So if PayID issuer's domain is compromised, they should probably change their private keys to have access to like the PayID resolves to a URL that belongs to this domain, and if the domain is compromised, it's general practices that a domain owner would take. I mean, I don't think we have a very good answer for how it would affect PayID. I mean, PayID is irrevocable. Like, it's the underlying domain or the domain owner who has to take steps to prevent whatever it is. I'm sorry, I do not have a good answer to this. No, it's good. It's a good open topic for discussion. There is discussion going on chat.payid.org on the Discord channel. We definitely invite people to kind of continue the discussion there. One more question, around like, what do you think is like the future of like the standardization of PayID? How are we going to be working with standardization bodies? How do you anticipate standards being set?
Yes, that's one area that we are really keen on and actively working on in terms of standardization. So we believe it's a protocol that belongs to community. You guys are the ones who are implementing this protocol, who are going to implement this protocol. So we have a bunch of documents that inform of RFCs, and we have white paper. And as I discussed in my talk, that there are several open questions that still need to be answered in terms of security and the protocol design in general. So the plan is to have working groups, as we have already organized one for security and identity and for travel rule solutions. We want you guys to participate in that, and the ultimate idea is to take this protocol to a standards body, such as what we are thinking of right now is to go for IETF or W3C maybe, and we really want this entire community to work on the protocol and make it standard. So I guess we'll be organizing working groups in regular cadence now. Everyone is welcome to join.
Yeah, definitely. We will be posting invites to the working groups as as we kind of narrow down the developers that are really active and helping make this standard. So thanks a lot, Anshul. Appreciate security is super important. You've addressed a lot of really good topics. At this time, I want to bring on Michael Zakowski back online. Michael is wearing many hats today, and part of his he's going to be discussing with Anshul how PayID supports travel rule, particularly with Trissa.
Perfect. So before we move on here, just want to add on to what Anshul said. A lot of the questions here coming in, really good questions. One of the things that we liked about basing PayID on the web tech stack is that almost all the security considerations, including things like domain expiry or things like cookie security, they reduce down to the standard web stack. So anyone who runs a user website right now is asking those questions and dealing with them in a fundamental way. What happens if Citibank.com loses their domain? Well, it's not good, so you should make sure that you secure a domain. That's not really necessarily a PayID thing, but more of a standard web stack. So what we liked is that's an area that's really well understood after 20 plus years, 30 plus years at this point of e-commerce and online banking and those sorts of things. So let's dive in here into a related topic here around travel rule and Trissa. So we saw earlier a demo about how PayID could be used to facilitate general exchange of metadata, and that includes using the PayID channel to fulfill compliance requirements, in particular travel rule. So on the next slide here, give a little more color about what travel rule is, and then we'll turn it over to Anshul, who's really the expert on the protocol design of how we're working with another protocol, Trissa, which is doing great work in facilitating travel rule compliance in the crypto space. So for anyone who isn't familiar, I gave a very brief overview of what travel is, but you might ask yourself, why does travel rule matter? I'm a dev here, and it seems a little abstract, compliance requirements. So what is travel rule? If you are a certain type of financial institution, say a custodial cryptocurrency provider or a traditional financial institution as well, the travel rule is a set of requirements that's pretty commonly implemented around the world that requires these institutions to exchange information on the senders and receivers of these transactions. So the name is a result of the fact that the payment information must travel with the payment. So this might happen in many hops. In the crypto sense, it's generally a sender directly to the receiver. This is a rule that's applied in traditional finance for many years, but it's recently been applied or deemed to apply to the crypto space as well. So an organization called FATF was brought up earlier. That's an international coalition of regulators around the world. They recently recommended that this start being enforced really actually in the current weeks, and that's meeting the FATF group again sort of as we speak to discuss how this looks going forward. So this is really a central problem here, but it's also pretty hard. If you are just presented a Bitcoin address from one of your users, say you're an exchange, and your user says, I want to send Bitcoin, one Bitcoin, which is well over the travel rule threshold, to a certain address, and it's a random string of base 58 numbers and letters. How do you know whether or not travel rule applies? Namely, if the other person on the other side of that transaction is a covered institution or just, say, a non-custodial wallet, for example, in which case it doesn't apply. So that's question number one. That's pretty hard. You don't have any way to contact that person from just looking at that address, and there's some solutions, including the one that Trissa has proposed. But how can we make that more elegant? And then the second question is, even if you've identified that travel rule applies, how do you exchange this information? You don't actually have a connection off the bat. And this has really big implications for the space. If you're a custodial wallet, the implications are pretty obvious. You have to comply with this. But it has pretty big implications for the space overall. Even if you're a non-custodial application, don't even touch custody in any way. Well, it turns out the custodial players are a really huge part of the space, and so what they do, what impacts them, is going to have a big impact on the space overall. Things like on-off ramps are particularly important to everyone in the space. So this is something that matters, and it's hard to deal with in the crypto space, at least. So how can PayID actually improve this? So we'll go to the next slide here. And I'll turn it over here to Anshul, who will go through some of the protocol details.
All right, I'm back again. Thanks, Michael. So actually, can we move to the next slide? I'll just talk about the technical flow. So while PayID protocol, can you all hear me? Okay, cool. While PayID protocol, I would say, can provide a standalone solution, a standalone framework to satisfy compliance requirements, its composable and flexible structure allows it to complement any other solution by providing for easier setup, better user experience, and an enhanced privacy. And to that end, one PayID extension that is in active development is an integration with TRISA, that is Travel Rule Information Sharing Architecture. It's a solution for WASPs that facilitate exchange of identity information between the transacting counterparties without modifying the core blockchain or cryptocurrency protocols. And integrating verifiable PayID protocol into the TRISA flow enhances the protocol in several aspects. So first, I'll describe how we propose to integrate PayID with TRISA for WASPs alongside describing its potential benefits. So for this flow to start, the participating entities, that is the originating WASP and the beneficiary WASP, they must acquire identity certificates for WASPs with extended validation. So these are the certificates that are issued by TRISA organization, TRISA CA, that verifies the identity of WASPs under some criteria, known criteria, and serves as a dictionary for their public key certs so that they can be identified and can establish secure communication channels with other WASPs. And on top of that, they obviously require these originating WASP and beneficiary WASP require WebPKI certificate. So how does the protocol start? The integrated protocol flow begins at the originating WASP as a PayID client. So the prerequisite here is that the originator of the payment must send a payment request that contains the beneficiary's PayID, just like the PayID protocol works, and the transaction information to the originating WASP. Now notice that the originating WASP at this point does not know if the other side is a WASP. And here is one advantage that PayID provides to the TRISA flow. That is, it allows the counterparties to indicate to each other within a protocol that they are WASP in a secure, unambiguous, and scalable way, and without having to use any out-of-band, less intuitive, and error-prone methods that are currently in use. So what happens is the originating WASP establishes a secure, mutually authenticated TLS session using their non-WASP WebPKI certificate with the receiving endpoint, because they don't know that the other side is if the other side is a WASP or not. Now, if this TLS session is successfully established, the originating WASP, that is the PayID client, generates a request, which among other things must indicate to the other side that they are a WASP. Now, upon receiving this request, the PayID server or the beneficiary WASP parses the request body to check if the other side is a WASP. Now, since the receiving side is a WASP and that they know that the other side is a WASP, they must tell the other side that they are a WASP and that they must fulfill the travel rule requirements, and that it's time to pass the flow to the TRISA client and server, because rest of the flow, that is the travel rule information exchange, would take place on TRISA client and TRISA server. So PayID server would generate, as you can see in step 3 here, a response which among other fields must contain an indication that they are a WASP, a redirect URI to redirect the PayID client to the TRISA server, and travel rule as a compliance requirement in the message body. But note here that the PayID server or the beneficiary WASP must not send the payment address information yet. And that's because the two WASP haven't yet verified each other and haven't agreed that they really want to do business with each other. This is another advantage of PayID, that is the originating WASP cannot really make the transaction or the payment before fulfilling the travel rule requirements. With the simple handshake protocol, PayID protocol, the WASPs have established if travel rule applies with cryptographic trail of communication, because all these messages are supposed to be signed. Now the WASP verification and travel rule data exchange will happen on the TRISA client and server. So upon receiving this message, the message that the PayID server sends in step 3, with a redirect URI, the PayID client or the originating WASP forwards this request to the TRISA client. TRISA client now knows that the other side is a WASP, and so they initiate a secure, mutually authenticated TLS connection with the TRISA with the other side using their TRISA identity certificate that I mentioned before. This happens in step 4 and 5, which allows both sides to verify each other's identity and to agree that yes, they want to proceed with the transaction. Notice that now in step 6, the TRISA client would send a message to the TRISA server that must contain the amount of the payment, the travel rule data, the beneficiary's PayID corresponding to which the TRISA client wants the payment address information, and all of this is signed. Now, upon receiving this message, the TRISA server would perform a basic PayID protocol with the PayID server by querying for the payment address corresponding to the beneficiary's PayID, get back the response, and prepare in step 8, as you can see here, receipt that must include beneficiary's information. That's again a part of the travel rule data that must be exchanged. This PayID to payment address mapping that they received from the PayID server. An acknowledgement, a signed acknowledgement that they received travel rule data from the TRISA client. And all of this should be signed. Notice now that the originating WASP in step 8 has received the acknowledgement that beneficiary WASP has received the travel rule data. So the originating WASP can now post the transaction on the provided payment address and receive a transaction ID. And then they can post in step 10, as you can see, a confirmation of the payment alongside its receipt ID, transaction ID, and all of this is signed. All of these messages are signed with the off-ledger private keys of the originating and beneficiary WASPs, which makes this entire communication non-repudiable. And more specifically, provides cryptographic proofs of compliance to both the sides. And with this, we can move to the next slide. So just to summarize all of this, PayID supercharges TRISA. By this, what I mean to say is that integrating PayID protocol into the TRISA flow enhances the compliance screening and privacy of TRISA, because as you have noticed that the payment address to make the payment is only sent by the beneficiary WASP to the originating WASP after a beneficiary WASP and the originating WASP has verified each other's identity and have decided to proceed with the transaction. And B, each side has received and acknowledged the receipt of the required travel rule information. And PayID protocol provides an easy, scalable, and unambiguous way to discover and verify counterparty. For originating WASP, it eliminates the risk of sending private information to the wrong entity. And for the beneficiary WASP, it eliminates the risk of receiving a payment from a WASP without having to fulfill the compliance requirements. So it facilitates information exchange with these proofs of compliance. And last but not the least, as PayID protocol's feature is, it provides a better and improved user experience. So that's how we propose to integrate PayID with TRISA with several benefits that it provides to TRISA. And that will be all. We also have, if you want to participate more and are interested in learning more, we have a travel rule working group. So it would be great if you can participate. And that will be all. And with this, Michael.
Yeah, and I'll just add on very quickly, the TRISA team is phenomenal. They are a member of the PayID Coalition. We're also participating in that effort there. A lot of common principles in terms of openness, peer-to-peer, lack of centralization based on web standards. And so it just made a lot of sense to partner with that effort to help solve really tricky problems in the space. So over to Warren. I don't know if we'll have time for Q&A here. I know we're running a little bit behind.
Great. Thank you both. We are 9 minutes behind, 10 minutes behind now. But it's really important and timely for travel rule, obviously, with FATF kind of recommendations coming out here shortly. We want to, at this point, take a step forward, actually, and look toward more future functionality. I'm going to be welcoming Ian to talk about how PayID can be applied particularly to commerce flows. So we're talking subscriptions, invoices, receipts, so actually businesses can actually use PayID to interact with, others. Ian, go ahead, take it away.
All right, can everyone hear and see me okay? Yep. Okay, great. Grab me with the silence for a quick second. All right, so my name is Ian Simpson. I'm an engineer here at Spring. And on the next slide, we're going to talk a little bit about the Open Payment Stack. What you're seeing are the layers of what we call the Open Payment Stack, which is a combination of addressing, payment setup, payment clearing, and settlement. The layer we're going to be talking about right now with regard to PayID Commerce is payment setup. On the next page, we can see a little more about what payment setup is. Payment setup has a few moving pieces on its own, including address verification and compliance. The piece you saw earlier during the Chef XRP demo from Neil Hartner, and that we're going to examine more in depth now, is focused on commerce flows for formalizing transactions between users and merchants or other organizations. We've outlined some points on the next slide detailing the impetus for this functionality. Our key principle is user-centric commerce via wallet-to-wallet interoperability, which enables sophisticated use cases like checkout, off-capture, and subscriptions in a homogeneous way across rails. We're also already looking at enhancing this with features like automatic forwarding of details, similar to what you experience with other wallet solutions, which streamlines the interaction between a customer and a merchant. We're also looking to integrate receipts and transaction history and more. The next thing we'll see is how these pieces fit together. To give you a brief visual of what this looks like in terms of moving pieces, PayID Commerce Server is trying to act as the glue between the wallet, which the user will be interacting with to submit payment, and the merchant site, which is trying to articulate complex transaction types like invoices or mandates. Finally, the transaction is validated by monitoring the payment rail. Next, we'll see what this looks like for invoices in greater detail. In the case of an invoice or push payment, the user would start at the merchant's website on the checkout page, where the merchant would discover the customer's wallet via their PayID and create an invoice representing the transaction. The customer would then be redirected to their wallet with details about that invoice to choose their payment rail, and after submitting payment will be sent back to the merchant where the PayID Commerce Server will confirm payment against that invoice via the rail. Moving forward, we'll examine what subscriptions look like. Next slide, please. Oh, sorry, you're on the right side. In the case of subscriptions, the flow is similar, except that the entity being used is a subscription instead of an invoice. We still rely on redirecting from the merchant to the wallet and back to confirm the flow, but the interactions are a little more nuanced after. In this case, we're sending the customer to their wallet to approve the subscription, but not to initiate the transfer of funds like we do in the invoice. The trip back to the merchant is for confirmation of the subscription rather than confirmation of receipt of funds. Behind the scenes, the PayID Commerce Server of the customer wallet notifies the PayID Commerce Server of the merchant that the subscription is approved, rather than any kind of token-based interaction via the browser. Up next, we'll talk more about how subscription payment works. After the subscription is created, we end up reusing an invoice flow behind the scenes. The merchant creates the invoice and creates a charge against the invoice, which results in the PayID Commerce Server of the customer's wallet, which pays the invoice. Once again, the ledger is monitored to make sure the payment happened, which allows the merchant to know that the invoice, and in this case the instance of billing against the subscription, was paid. Next, let's talk more about the benefits of PayID Commerce. First, you get a seamless user experience since we minimize the amount of information required to be known and or typed by the user. We achieve interoperability because the merchant can orchestrate and trigger subscription payments with user consent through a uniform open API that will work across wallets and across payment rails. It's simple because the merchant's PayID checkout server provides a single integration API for all commerce-related transactions and functionality, such as updating inventory, accounting, etc. It's secure because the interactions are primarily server to server, which improves security. And it's empowering because it allows the sender to aggregate and manage all subscriptions in a single place like your wallet. And with that, I'll turn it back to Warren for any questions.
All right, thanks, Ian. So we're actually we didn't get a ton of questions, I think, because people were kind of focused on some of the more of the security. So we're gonna transition, try to catch some time back to Javi and Meyer, who are our partner engineers. They are focused on helping businesses integrate PayID. A lot of you partners on the call have probably integrated with or interacted with Javi and Meyer. So Javi, Meyer, if you guys can come on and discuss a little bit how to integrate PayID into a company's servers.
Hello, hi, I'm Mayur.
Hi, I'm Javi.
We are partner engineers on the Spring team, and we focus on helping partners integrate PayID into their applications, as Warren mentioned. So today we're going to be discussing how you can make use of what's available with PayID now using the reference implementation. And so there are two main efforts. One is allowing users to send money to a PayID, and two is generating PayIDs for your users so that they can receive money easily. So you can see that there isn't too much of a lift. It's pretty straightforward. And I'm going to be going over send, and then I'm going to hand it over to Javi to go over receive. So from a send perspective, the basic PayID flow starts from the client application, and this can be a web app or a mobile app. And we typically want to insert the PayID into an existing flow by modifying the destination field to accept the receiver's PayID. So this is your standard destination input field that says send to or withdraw from or withdraw to in the context of an exchange. The only logic change that needs to happen is to send a GET request to the public API endpoint that corresponds to the receiver's PayID. So if you recall, every PayID corresponds to can be directly translated to a public API endpoint where you can get the underlying payment information. So this will, of course, return the underlying address of the receiver according to the header that was supplied in the initial request. So in this particular example, we have BTC mainnet plus JSON, and that means that the PayID server is going to return the Bitcoin address. And then once you have this, you can just use your existing transaction logic to make the payment. So just to reiterate, there is no change in the transaction logic that needs to happen. You just use what already exists. I think this question kind of came up a bunch of times in the chat already. And you can do all of this with the Spring SDK, which is going to be talked about in greater detail during the next section. Right now, I want to show you an example of a great send implementation via PayID in the next slide. Cool. So this is the Sum app, and I'm sure many of you guys have probably already seen the Sum app. It was created by XRPL Labs. And I like this integration in particular because it proactively detects whether the PayID is found. And that's a pretty easy feature to implement. All you have to do is send the GET request every time the user types in a new character, or just check if it's already in the address book. And it really enhances the user experience. So this is a pretty good model of what send should look like via PayID. So yeah, one thing that can be done in multi-currency wallets is displaying all of the rails that the receiver can accept payments on as soon as the PayID is typed in. And this can be done with the application/PayID plus JSON header. The slate typo here, it should say application slash, it should be an accept header that says application/PayID plus JSON. But by using this response, you can create a flow where the user gets to choose which payment rail to send on as soon as they type in the PayID. And so now I'm going to hand it over to Javi to talk about receiving via PayID.
Thanks, Mayor. So if you want to receive payments through PayID, or you want to offer that to your user base, the easiest way is to run the reference implementation, which is open source and is available to download for everyone. So I'm going to go through the touch points of that integration, and then I'm going to show you that integration in action. So typically, what you will have is like a mobile app or a web channel where users can enroll and opt into the PayID scheme. That channel will have communication with the backend, a middleware, and that middleware is the one that is going to be talking to the PayID server. The PayID server is a Node.js process, so it's not resource hungry, and it's very easy to run. And it also offers two APIs, one public API, which is to be consumed by partners, and a private API that is to be consumed by your integration layer to create PayIDs and to amend addresses linked to a PayID. Usually, you will have a reverse proxy on top of your PayID server, so you can expose that to the public internet under your own domain, and communication with your partner will be under TLS 1.3. If we go to the next page, we're going to see this integration in action. You can see on the left-hand side is the Tangent application, where the user will choose a username, and when they click send, that will connect to the integration middleware that it will end up making a request to the private API of the PayID server, as you see in the right-hand side. As you can see, it's a very simple request. It's a post request to the private API, where you tell the PayID server what PayID you want to create and what address is linked to that PayID. So as you see, it's very simple to integrate. But before we finish, I'm going to pass it over to Major. He's going to talk about PayID metrics.
Thanks, Avi. So yeah, I just wanted to mention as we close out that you can also enable Prometheus metrics on the reference implementation by changing just two environment variables. And this is useful because those metrics can be pushed to any Prometheus metrics aggregator. And you could run one locally as an admin portal to track the total number of PayIDs and the number of PayID lookup requests. And that's helpful for you to understand like how your users are making use of the PayID feature. And we also have a metrics aggregator that you can push metrics to at this URL. And yeah, that's everything. We're happy to answer any questions now. So over to you, Warren.
All right, thanks, guys. I think you pretty much demonstrated how easy it is to integrate PayID. Michael said, before myself as well, we're able to deploy PayIDs, and we're not, server administrators by any means. So it should be pretty straightforward. There's great documentation. A few questions that kind of popped up. How many PayID servers are actually required if an organization is going to be running PayID?
Yeah, so for a production server, as I said before, PayID server is not very resource hungry, but you need at least 2 servers to have high availability. Then how do you scale more than that? It depends on the traffic and how many requests you get. At least I would say 2.
And on that note, how resource intensive is a PayID server?
So you don't need a very powerful server. You just need maybe with and that should be enough to run the PayID server.
I think we had some audio issues with you, Javi.
Can you hear me?
Yeah, we can hear you. I think the key takeaway is it's not very resource intensive.
Yeah, no. Just one CPU and 500 meg is enough.
Got it. Interesting. Okay. So what is the header format for non-XRP Bitcoin ETH addresses? What does that header format look like?
That's a good point. For in the documentation, you'll see application / BTC plus mainnet plus JSON for our dash mainnet plus JSON for BTC, and then for XRP it's similar, and they all follow that same pattern where it's the ticker symbol dash the environment, which is a mainnet, or it's the mainnet or the testnet name plus JSON. So it all follows that standard format. So you could use that for any currency, any cryptocurrency.
Right. One other kind of like which like team members should actually be involved in actually integrating PayID?
So for the send side, it would likely be your iOS and Android developers, and probably your front end team. For the back end, you're definitely going to it'll largely fall onto the DevOps team's plate. So that's who you would want to loop in when you're integrating PayID.
Right, and then we have documentation for what types of environments currently.
Yeah.
Which types of environments is there documentation for currently?
For so yeah, you'll be running a Docker container in whatever environment you currently have.
Okay, we've got a few more questions. So I think one of these that bubbled up was, if you have, say I have, multiple XRP addresses or multiple Bitcoin addresses, can I use one PayID for all those addresses, or like what is kind of the recommended way that I can manage like multiple addresses?
Yeah. So right now the protocol only returns one address per environment and network. So you can have one XRP ledger address. If you need two XRP ledger addresses, you probably need to create two PIDs right now. That would be the way. Yeah.
Okay. And then another one, what's the difference between the PayID public API versus the PayID private API?
So the public API lets you see what the underlying address information is, and then the private API is specifically for the reference implementation of PayID. When you're using the reference implementation server, you can change, create, update, destroy the users, and the PayIDs.
Right. This is awesome, guys. You did really well. Anything else you want to add?
Nope. I mean, overall, it's been really straightforward to help partners integrate. And we found that it seems like as soon as the launch happened, a lot of people have been able to do it self-serve and not require any hand-holding. So I highly encourage everybody to go out and try running their own PayID server and getting these implementations going.
Yeah, that's a great point. PayID is an open protocol, open standard, so self-deployment is kind of the way to go. If you do get stuck or you get blocked, I recommend joining the chat.payid.org Discord channel. A lot of developers will be monitoring that to help people get unblocked. We want to get as many PIDs deployed as possible. So appreciate you guys. Thanks for dialing in. So next up, I want to bring in Kiefer Taylor, who's one of our lead engineers on the SDK, and Amy Corso. They are going to be covering, ways to send using PayID for the SDK.
Hey, so I'm Kiefer Taylor, and I work on Spring SDK over at Spring. So if we could go to the next slide. So I just wanted to give a brief intro to what Spring SDK is. It is the development toolkit for basically everything that Spring touches. So we work on a variety of protocols that are all open. So XRP, ILP, and now PayID. It is a cross-platform SDK, so we publish libraries in Java, JavaScript, and Swift. So hopefully on like most major platforms, you can pick up Spring SDK and just sort of start building with it. All of these libraries have similar APIs, they behave in similar ways, they have similar constructs, and they all power basically everything Spring builds. So they power our web wallet, they power the charitable donation flow that you saw earlier in the day, and basically we just build on top of our own things and eat our own dog food there. And then lastly, Spring SDK tends to be a pretty opinionated view of how to do common tasks and make them super easy for developers. So like one of the metrics that we like really look at is like how few lines of code would it take someone to get up and running and like resolve a PayID, or how few lines of code would it take to like move XRP across the ledger. And so we really want to make that like super simple for people who work with these protocols, that you don't necessarily have to understand how the protocol works. You just have to understand how to write programming, like basic programming languages, and use that to sort of build higher level things in your app that leverage these really cool technologies. So with that, I'm going to turn this over to Amy, who's going to talk to you a bit about PayID and the Spring SDK.
Awesome. Hey guys, I'm Amy Corso, and I'm on the Spring engineering team over at Ripple as well. And I've been working on developing the SDKs with Kiefer. So let's just jump right into the code here. I'm going to share my screen. All right, so hopefully we're looking at VS Code here. You can yell at me if that's not the case. So the SDKs are available through typical package managers. So this is an example of using our JavaScript SDK. So you can see here we're just importing Spring.js. And let's take a look at the code maybe before running this the demo. So the SDKs currently provide 2 clients for working with PayIDs, for resolving PayIDs to underlying addresses. So let's actually take a look at this client first. So this is a generic PayID client, and you can see here that it's instantiated without being bound to a particular network. So this generic PayID client has a couple of functionalities. It can resolve a PayID on a specific network, or it can resolve all the addresses associated with a PayID. And it can also parse and validate a PayID, so that splits a PayID into the component path and host, and it also validates that the PayID is valid. And so when using the generic PayID client, you provide the PayID and the network for which you want the address at call time. So this little snippet here is an example of resolving a PayID, in this case, Alice, dev, etc., on the Bitcoin testnet. And you can see how simple this is. Basically, one line of code to instantiate the client and another line of code to actually make the call. And so here at Spring, we also work a lot with the XRP ledger. So we have another PayID client called XRP PayID client that has similar functionality, but what we do here is we instantiate this client with a particular XRP ledger network, which is expressed here as an enum, so it's kind of hard to screw that up, and it allows for some internal sanity checking. And then the other thing to note about the XRP PayID client is that this client always returns addresses in an X address format. For those of you who don't know what an X address format is, it's a format that encodes a classic address and a destination tag into one address. So it's a safer form of address to use because it checks validity and it makes it impossible to forget your tag. So with that said, let's actually run this demo. And you can see here that using our generic client, we were able to resolve a Bitcoin testnet address, and using our XRP PayID client, we resolved an XRP ledger address there. So one of the key design considerations that went into the SDKs was to use sort of a centralized core architecture to handle the networking components and to make that code highly reusable. So that's actually not something that you guys have to know about or care about, luckily. That's kind of the point of the SDKs. But the effect has been that overhead pays off in sort of ease of development across multiple language and in terms of adding additional features. So I have essentially an identical demo here in Java. So now we're looking at Java code. And you can see here that, our generic PayID client looks essentially identical, our XRP PayID client identical, our method signature identical. We could run this one too. So yeah, that's the idea behind the SDKs, is to keep everything as consistent and similar as possible. Let's see, you guys resolving? Great, so there's our same address resolution here in Java, and if we look over at the Swift example, it's also essentially identical, but we see, like, for example, the crypto address resolution method is a little bit more idiomatic here to Swift. But yeah, all right, so with that, I will pass it back to Kiefer, who's going to show us a little bit more about how we can integrate across services using Spring.
Sure, so I'm going to share my screen as well. So as I had talked about in the beginning, one of the things that we have in the SDK is support for multiple protocols. So even though we support PayID, we thought, hey, what else can we do with PayID and XRP? And so one of the cool things I want to show you just real fast as a demo is a composition between XRP and PayID. So I have this demo on my screen, which is written in Node.js. And basically we have like an XRP client, which is a class that interacts with the XRP ledger. We have the XRP PayID client, which is this class that Amy talked about, and that knows how to resolve PayIDs to XRP addresses. And then we can compose those two together into a Spring client, which actually knows how to talk to both of those protocols and make them work together. And so in this example, we're just going to make a Spring client, and we're going to use it to send some drops of XRP to a PayID directly using a wallet. And a wallet is just a lightweight object which encapsulates keys. So this particular wallet is on testnet, and it's generated from this seed. So I can go ahead and run this demo, and basically with those like 4 or 5 lines of code of instantiating these objects and wiring them together, we can actually send 10 drops of XRP to Alice at dev.payid.spring.money, and it's from my wallet address, and I get a transaction hash. And then we queried the ledger using Spring, using XRP client, and the XRP client confirmed this transaction succeeded. And then just following along what Amy talked about, we have this same demo in Java. It looks basically the same. All of these classes exist in similar ways across all of the SDKs, all the SDK libraries, modulo some like idiomatic language things. But I can go ahead and run this, and this will go ahead and build, and we should see, hopefully, yeah, there we go. We should see the similar output here. So we're going to send another 10 drops to Alice. And the reason this send is slow is we're actually waiting for the transaction to settle on Ledger. So hopefully, perfect. Yeah, so we get another transaction hash out. And then at the risk of boring you, we have the same demo in Swift as well. So I can go ahead and run this, and this will also do the same thing in Swift. And the point of having these things is basically that the point of having all these libraries is that you can interoperate with like whatever language you're using to build your app or your library or your binary or your server. Like we have a surface for you to integrate with. And if you're like a mobile shop and you have Android developers writing in Java and you have iOS developers writing in Swift, those two teams don't have to learn different language paradigms, right? Like an XRP client exists in Java, it exists in Swift, and it exists in JavaScript. And so when you start to understand how these things all fit together, you can move between languages or build multi-language things very, very easily. So again, this demo we sent another 10 drops to Alice, who now should have probably 30 drops of XRP in her account, and we got a transaction hash out of it. So that will finish our demos. If we could go to the next slide, which I can't see anymore. Perfect. So if you want to go get started with Spring SDK, everything we've shown today is live right now. It's all published. You can go grab these libraries from your favorite repository manager. All the demos that we just showed are also open source, so they live in Spring SDK demos under the Spring-Eng org on GitHub. And then we have links to Java, JavaScript, and Swift libraries. And then if you have any questions, I'm happy to field them now. Otherwise, you can bug me or Amy later, or one of our other teammates on forum.spring.io. We monitor it fairly often, and we'd love to hear feedback or hear your questions or help you get started with Spring SDK. So with that, I'll turn it back to Warren. And
thanks, Kiefer. So Kiefer, we actually had one question. There was a few Golang and Perl fans in the crowd that want to know when support could be available for Golang and Perl, or if how can a developer actually get involved in implementing the SDK in their own languages.
Yeah, totally. So one of the nice things about Spring SDK is we actually build using a reusable network layer. So we use gRPC bindings, which let you generate network interfaces in a lot of languages. So you can get a lot of that stuff for free, and then we provide a common core JavaScript library that you can bind into as well. So you'll never have to go parse your own PayIDs unless you want to. You can actually just hook into our code. So I believe Blair has started work on a Go version of Spring SDK. I'm not actually sure on its status at the moment, but we're very interested in building additional language bindings for this stuff, and we're very interested in making it more and more accessible and providing more and more surface areas. So if you have
I think
a language binding, we'd love to talk to you.
For sure. Yeah, I think I've seen community support for Go, Python, Ruby. I think that's it.
There's a Rust implementation,
and then Rust too. So obviously, super easy to be able to support other languages. So if you're a big Perl fan, we highly encourage you to. You could spend a better half a weekend probably spinning it up. I've seen it done actually at a hackathon where someone just wanted to write their own implementation, and they did. So awesome. Kiefer, Amy, thank you so much for joining. Appreciate great work, and we'll check you out on the chat forums.
Cool.
So next up, I want to introduce Ben. Ben is the CEO, co-founder of Withdrawal. Withdrawal is a payment network that's been around for quite a long time. So Ben is a very entrenched mind when it comes to payments, and we're super happy to have you. And just to kind of discuss a little bit more about what you're working on and how you see PayID benefiting in the long term. Can't hear you. Still can't hear you. Okay, now I can't hear you. I can read lips, but I can't hear you. If you want to go ahead and just try to do a refresh, we can spend a few more times with question. Yeah, Okay. We're running fast anyway. We're 5 minutes ahead of schedule. So just a few more questions that bubbled up. Looks like there's been, let's scroll down. Definitely, upvote the questions at the bottom so we can start to see some of those populate. We'd love to see, more and more. So someone asked, can PayID support telephone numbers as an account identifier? This was an interesting question, particularly, in places like India or other countries that use telephone numbers. So currently there isn't a proposal for this, but we're always open to RFCs. We want to make sure that that we're allocating and trying to have the widest kind of breadth of different identifiers to include. So we'd love for anyone to publish an RFC. There's a lot of developers are actively implementing the current RFCs right now on GitHub. Ben, you with us?
Yeah, let's try this time.
All right, there he is. See, refresh. You didn't have to throw your machine out the window.
Man, that's why we have test runs, Should have just worked. My bad.
All right, welcome back, Ben. Take it away.
All right, everybody. Making sure, can you give me an audible? You can see my screen?
Yep, we can hear you.
All
we
right,
can see the screen and hear you.
It's all working. Well, welcome to my basement, everybody. I appreciate you having me today. If you want to follow up with me at all, you can just find me on Twitter or shoot me an email at b@dwala.com. For those that aren't familiar with Dwala, Dwala is a programmable payment platform. Essentially, our clients embed our APIs into their software applications to enable payments for various reasons. And APIs are nothing new to this particular crowd. So a good way to think about Dwala is that our clients build their own interfaces and then utilize us to connect to complex regulated infrastructure, specifically for moving US dollars. I'm going to talk a little bit today about how we're opening the platform up so that developers that are building applications for non-fiat currency, non-USD, are actually able to start integrating with Dwala. Our client base is really responsible for the innovation and the end user experiences that are built on our platform. That's everything from automated savings application to fractional ownership applications to payouts to payments at gas pumps. There are so many different uses of the technology that we could be here all day. But the important thing to kind of call out here is that each one of our clients has a different user experience, a different interface, and the commonality between them is really just they want to program a payment. They want to program money going from one bank account to another. Obviously, that's pretty similar or has applications that are similar to how you could use PayID. And in our world, every payment has a source and a destination on platform. You got to know where the money comes from and where it's actually going. Now, not every payment interaction is a payment, and that's something that I think is really unique about PayID and where potentially there's a lot of value for platforms like Dwala and even Dwala's clients. When you look at those data integrations that are not related to moving actual money today, they look like card issuance, notifications in Slack, real-time risk scoring, or shared tokens with platforms like Plaid. These are obviously just extending our platform with partners using data in ways that complement the transaction. And that's a place where I think PayID can be really interesting on the partner side. Now, partner applications authenticate into client applications. And the reason that can be really powerful is that essentially with a single implementation and an auth, the partner application, which can be built by a company, an individual to support a technology, product, protocol, really whatever you want, can get access to all the data inside of a client application. So all those millions of customers that are inside of our client applications can be essentially indexed with new addresses, for example, that could open things up pretty substantially. And my personal perception is PayID helps solve a four-dimensional problem. And four-dimensional is just to say a hard problem. PayID helps our clients pre-negotiate before the payment, to get the payment credentials before the actual payment is made. And sharing the payment credentials is actually a more difficult technical problem than I think most people realize. Now,
that non-payment interaction also starts making payments possible cross-platform, not just our platform, but others as well. And I know we have clients that have already implemented PayID, but I haven't seen their implementations yet, and I'm excited to see it. One of the things that I think is really unique about this current snapshot in time is interoperability is essentially enabled by a technical adoption, not regulatory mandate. And in Europe, it's really by regulatory mandate, but in most of the world, and also specifically in the United States, the opportunity for us to essentially open platforms really quickly through developing new things is pretty astounding. And we're getting to a point where every payment has a source and destination off platform as well, and that's largely enabled by technologies like PayID. Now, the reason I think that is so incredibly powerful is if you think of Withdrawal as like a single node, that node is not really that important on its own. But when Withdrawal distributes its product and it's used across 19 different verticals that service n number of clients, that service millions of end users, you can start to get to a point where you see through a single integration how you can light up all these millions of accounts that are already validated, that are already known. And I feel like that's a really special thing that just 10 years ago wasn't possible. I tried to figure out a slide with 1 million dots, but it just ended up looking ridiculous and I kind of failed, but I felt like I had to use the slide anyway. So that's nowhere near 1 million dots, but hopefully you get the idea. You know, on the Withdrawal platform, each app is a registration or has a list of registered entities or customer types that are all trusted receivers. But the apps really can't talk between one another. They can't see one another. And my hope is that through this and other experiences, we're actually able to find someone to, and partner with someone to build a PayID implementation that helps our clients actually discover some of the payment credentials across the applications. And in doing that, lights up all those trusted receivers in a way where the applications built with different financial institutions start to become more discoverable, and transactions can start to seamlessly occur between different applications built on different platforms, whether or not that's directly with the Wells Fargo or a number of customers building on Withdrawal's platform. And I think the logical evolution for PayID here is that as you're creating these pre-negotiated payment instructions across a single currency and settlement infrastructure, you're able to start thinking about, well, how do we extend it to a second ecosystem? And in a platform like Withdrawal's that can actually onboard MSBs, regulated financial institutions, inside of a client application, you start to get to this really exciting opportunity where you can start to enable off-platform cross-currency exchanges, which historically has actually been really hard. To do that from scratch could take somebody 10 years. It took me 10 years. But now, essentially, it's possible by adopting the right technology and protocols in the right order, which I think is a super exciting thing currently for developers. And I think the snapshot in time is really special because the power of what gets built is now with platforms where it used to be almost solely controlled by the banks. And so people that are implementing PayID are creating interoperability in a way that, again, I say 10 years ago, because that's kind of when I got started in some of this stuff. Back then, it wasn't even possible. Now my job is really to support impactful technology and enable new innovation. PayID is new innovation and something I think is going to be really impactful. Now, if you're interested in building a PayID implementation that could be used across the entire Withdrawal platform, I would very much like to talk to you. The developer docs are open and public, and the same implementation that is built when you're a client application is a little bit different than a partner application, because partner applications can be built by people all over the world. You don't need to be in the United States. You just need to be a really good developer that can pass the information security review and also support the application well. So if that is something that interests you, I'd love to hear from you. Again, on Twitter at VPMill, and then just shoot me an email at b@Withdrawal. I am extremely excited about what PayID is doing, and I think it starts to pave the way for interoperability between platforms in a way that we simply haven't seen yet. So thanks for building it, and thanks for having me.
All right, Ben, thanks a lot. I appreciate your time. Glad we got to troubleshoot those and exciting presentation. It's a call to action for developers to build for applications like Dwolla, because it's going to make Dwolla a lot more useful for everyone. Appreciate it, Ben. So next up, yeah, thank you. So next up we have Marissa from Liquid.com. So Liquid is aptly named one of the most liquid exchanges in the world. I think they've done to the tune of about $50 billion worth of trading in the last 12 months. So Marissa is going to talk about the exciting use case of how exchanges can actually use PayID. So Marissa, if you're in the queue, go ahead and join. She's on her way. I'm particularly excited. Yes, Marissa, you there?
Yes, I am. Sorry, I'm dialing from Singapore, so I'm not going to be showing my video today, since it's about 3:50 in the morning now. But thanks for having me here. My name's Marisa. I'm part of the Liquid Exchange, part of a new division that we're just beginning called Partner Solutions. And I just wanted to introduce a little bit about Liquid, our background as a crypto exchange, and then also kind of go into some of our new developments that are coming into the payment space. Liquid Group was started in 2014, previously known as CoinX, and we have about 200 employees globally. We've been predominantly headquartered in Japan as the first licensed cryptocurrency exchange, and also located in Singapore and some of these locations here. So whenever we heard about PayID, I guess compliantly working with the FATF, that was something that really resonated with us. And currently as an exchange that is regulated in Japan, and then now going for our Singapore license, it's something that's really relevant and important to us. Just a little bit about our history is that we've always been, we started as a fiat to cryptocurrency exchange. So we've always been working very closely with banks and trying to make it easy for users to onboard and purchase their cryptocurrency for the first time. Like I said, regulation first, we were the first licensed exchange in Japan and currently hold about 60% of the trade volume for Bitcoin JPY, and definitely have the deepest liquidity in terms of building that order book. In 2017, we also conducted this cash ICO to basically fundraise with our white paper to build something called the World Book. And what the World Book vision has been is to basically bring in all different liquidity sources from global exchanges and basically put those prices within our order books in our exchange and kind of combine liquidity. And we did that first implementation in 2018 by basically combining our fiat to cryptocurrency exchange and our crypto exchange called Cryptos. And that's what we made of Liquid. And with that, we've been making tons of new enhancements, and one of the key things that we do is this technology called multi-market orders, which kind of is the building block for the World Book. And with the multi-market orders, what we use is our Bitcoin Japanese yen liquidity, and we apply that to other fiat to crypto markets, like, say, for example, Bitcoin Singapore dollars or Bitcoin Hong Kong dollar. We do the FX in the background and are able to price, deeper books for those pairs. And then now coupled with that, we've actually all added that to some of our altcoin markets. using a Bitcoin pair. So say, for example, that somebody wanted to trade, say, a token that doesn't exist on our exchange, say, for example, an altcoin, or even across different protocols, say that they want to trade like Dash to XRP, for example. We currently don't support that on the order book, but using our multi-market order technology, since we have both the BTC pairs for those currencies, we're able to synthetically create prices and I guess offer liquidity in these markets. So that's just a little bit of background of some of the technology that we've been building in our exchange. Is kind of this MMO capability, and now we're currently integrating with other exchanges as part of the World Book to then also bring in liquidity into the liquid. That's kind of what's been going on the professional trading side. And in addition to that, we've also been, kind of building on the foundation of making it really easy for and fast for traders to not only deposit any crypto assets seamlessly within, seconds. We implemented like zero confirmation BTC deposits. And then also we've been probably the first exchange in the world to integrate multi-party computing technology across all of our cryptocurrency withdrawals. So what does that mean is that basically when you submit a withdrawal request, instead of doing a cold wallet, movement to the warm wallet and releasing the funds for our users and our traders, like a couple times a day, we're basically now moving to the MPC solution where we can release funds almost near instantly in pretty much sub 1 minute withdrawals. So that's just some background about our exchange. That in terms of technology, we've made the MMO, and we're continuing to build on this World Book, and also just really enhancing our service levels. And it's great to create as this trading venue, but the thing that we realized is that this infrastructure can really be used for payments. And that's where kind of the vision of our new product called Quick Exchange has been developed, is basically how can we use our strong infrastructure of being able to quote currencies in different prices, use our liquidity, the ability to recognize deposits, and also be able to process. How can we use that as kind of a payment infrastructure? So that's kind of some background. And we now have basically our beta version running of our flexible payment API called Quick Exchange, and a widget that can not only process, fiat crypto, or also kind of crypto to fiat payments. And the way that we see this kind of working with PayID is we hope to kind of, we don't want to be doing, KYC for every single, small crypto payment transaction. And so I think PayID having a universal identifier can really help us be able to send these payments seamlessly and make it a much better user experience. And also be able to potentially send things. I know right now that PayID is not interoperable with different blockchains. So, one payment recipient payment sender wants to send to a recipient, then both sides need to be able to support Bitcoin addresses, for example. And perhaps that maybe with our Quick Exchange product, we'd be able to support, different protocols and chains, be able to provide the quoting and, enable the sending across different protocols. So with Quick Exchange, we shared a lot of the same vision with PayID, where It's really designed for kind of non-crypto natives, and user experience has always been, the number one thing. And I guess on the surface, a lot of people think some of parts of what has been developed so far might look like a Changely or Shapeshift type of product, but the background is very sophisticated and built on our Worldbook and MMO. And yeah, pretty much you can see what I covered here with the fast and secure delivery using MPC. I just wanted to go ahead and maybe show you guys also a demo. But the other thing that we wanted to emphasize is that we noticed that in order to bring more people into crypto and really service payments, we didn't want to have people be forced to create an account at Liquid. So this is really designed to be 100% white labelable for partners, and a new partner API for people to use. You can still see my screen here. I'll just show kind of the fiat crypto we have in here. We've implemented card payments. In here we can purchase, say, with Aussie dollars, buy Bitcoin. And we've created this to be an iframe widget so that people can easily use. And it's a very quick, you get the transaction cash here. And then I'd also like to show maybe just a visualization, of using our API for, say, some crypto swaps. So say that I wanted to go from Bitcoin to Ripple, for example. We also think that this widget, you can hide certain aspects of it and have guaranteed delivery. The, e-commerce provider. Okay, let's see. So I guess the point is that we can put in any settlement address. So, say that the merchant wanted to receive USDC, as a stable means. What this API does is that it provides a Bitcoin address, and as soon as it's received, it auto-converts it and delivers it to a non-custodial wallet, or whatever wallet that you designate. So let's do the same thing with XRP for the sake of the example. So I can easily just, you can feed this via API or copy paste it here. And then we display the address as soon as the payment is sent. Say that it was sent via PayID to this Bitcoin address, then it'll auto-convert and it could deliver favorable to the recipient. That's just another example here. And there's lots of creative ways to work with it, and we have a well-experienced team that is working on this product. And so we'd like to we're really excited to be able to collaborate with more members of PayID and figure out how we can better serve payments using this product. So our initial, developer B2B APIs are here, developers liquid _kex B2B. And we also just released our copy paste, widget code with different styling that our different partners can integrate. And it basically just shows these two screens, but you could also hide certain areas and use it for e-commerce. So we hope to be able to, similar to what BitPay is offering, be able to offer integrations into different e-commerce widgets, shop-in plugins, and make payments really or crypto payments really part of everyday life. Yeah, that's covers most of my summary of what I'd like to share with you guys. And, I'd love to invite people to reach out to my email if you guys have any questions or interest in working together on our Quick Exchange API, and also with how we can tie it in with PayID. So thank you so much for having me. I know the majority of the presentations were full-on demos, and we're only just getting started, but we're really excited to be here, and thank you for your time.
Thanks a lot, Marisa. Appreciate the showing the use case for exchanges. We're particularly excited about exchanges adopting PayID. An exchange, any exchange, you could have any number of different cryptocurrencies to help, actually streamline those all into a single address is going to help a lot, I think. So with that, I want to make sure that we just do a little bit of kind of closing out, just to recap. So we have quite a lot today. We had, we opened with Brad Garlinghouse and Ethan talking about kind of the vision for PayID, working with the coalition of 40 plus companies. We heard from David Schwartz more about the technical vision around identity more broadly. We heard from the lead product manager, Michael Zakowski, to kind of do a tech talk on PayID itself. We heard from a number of different partners. We saw some awesome demos. PayID is very much live. A lot of people have, asked, is this live yet? When it's going live? It went live on Thursday last week. It's open source. It's available on GitHub. There is the actual Discord channel that you can join, chat.payid.org, which will actually forward you over to the Discord channel. There's active discussion going on there. We anticipate that will grow. You can also get a hold of us at info.payid.org. It's a great email just to ask generic questions, and we can kind of respond to you that way. So, really appreciate the time. Next slide. So we are officially kicking off a hackathon as of right now. Hackathon.payid.org. So this hackathon is going to be 6 weeks, held virtually on DevPost. So DevPost is one of the largest platforms for hosting hackathons, and we're going to be hosting it there. Submissions will be open until August 2nd. That's a Sunday. You have from now until August 2nd to submit. Their submission requirements on that page that will give you kind of detailed look into what you actually need to submit and to qualify. August 6th, we will be having an award ceremony with a number of judges that we're actually going to be announcing in the next couple of weeks. We are pretty excited because PayID is a pretty popular technology, and it's only been around for a week. Imagine, it kind of building up more. So we're working on, with some exciting judges. We're going to be announcing that in the next couple of weeks. There's $25,000 in prizes right now. The winners take home the grand prize of $15,000. There's a second kind of runner-up prize that gets $5,000, and then third prize gets $2,500. There's also going to be 5 prizes of $500 each that are issued to honorable mentions. So we have about 8 winners that are going to take home some crypto, actually, some XRP. So we look forward to evaluating and seeing the submissions. Chat.payid.org is going to be your go-to for getting feedback, for giving feedback. We're really, really passionate about getting feedback on PayID. It's only a week old. We've been, working on it with over 100 different developers across 40 different companies for the better half of 2020. But, we want to make sure that we're building, the right things and hearing from you developers in the community to kind of help us steer. On that note, we are doing a lot of development on the working groups to make sure that this is a standardized protocol. And Anshul mentioned it before. If you're interested, particularly getting into the standardization of the actual protocol, then please reach out to us, info.payid.org, with a request, and we can send you invite to the working groups. So I know that there's actually been a lot of questions about ILP, and I noticed. So PayID does support ILP, very much so. We could think of ILP as like analogous to PayID. It helps to improve the actual onboarding experience to ILP. Some people ask, can PayID support multi-currency? So if you're sending one currency, receiving in another, and PayID itself can't, but it sits on other existing networks that can. So ILP is a perfect way to do that. ILP uses connectors to help bridge different currencies. PayID sits on top of that and makes it super simple for integrating that. So we're really excited about how all these different technologies can be combined to really make money move like information. So we're pumped to see that happening. We're actively involved in with the teams that are working on Interledger. We want to all come together and help make PayID beneficial for all communities. So next slide. I just want to leave you with this slide, and then we're going to close up. But this is a great link. It's a way to fill out your developer profile. This gives the team information on who you are and what your interest level is, so we can kind of continue to steer PayID in the right direction. It's just a quick bit.ly /pay-ID, and it's a short form. It's like you can fill it out in 20 seconds. But this is really important to help us, figure out, who we're talking to, what type of people are interested, and that we're actually, including, their voices. So appreciate everyone today. We're going to keep this slide open for a couple minutes, but thank you, everyone. There's been an awesome team from, it's been supporting this presentation and conference behind the scenes. Miguel Aquina, he's our Wizard of Oz, who's been operating all of Blue Jeans today. He's been awesome. Jimmy Chang, he's been our executive producer for this whole thing, and has been an awesome person to work with. Andrea Schwartz, who kind of leads events, and Devin Carlson. So all that whole team has been really awesome to work with. We appreciate them. They're in the behind the scenes, kind of making all this stuff happen. But we wouldn't be here without them. So appreciate everyone today. Bit.ly /pay-ID, and we'll see you in the chat rooms. Thanks a lot.